This is a video series to help you guys to prepare for DP-203 exam, which is a data engineering exam on Azure. In this series, I will try to cover all the topics which are outlined on the Microsoft official website. Some prerequisites for this video series. You must have understanding of data concepts such as relational database, big data, OLTP, which is known as online transactional processing, online and OLAP, online analytic processing, etc. And some level of familiarities with the Azure Cloud Data Services too. In this exams, these are the skills which will be measured. And you can see that it's divided into 4 sections. The first one is the design and implement data storage, which have the highest weightage, which is around like 40 to 45%. The second section is design and develop data processing, that is 20 to 30%. And after that comes design and implement data securities, which is about 10 to 15%. And the last is monitor and optimize the data storage and processing with the same weightage as the data security. So we are going to acquire all these skills in this video series in the same sequence. In today's video, we will see high-level data store models for various data types. So without further ado, let's start. So today we are covering these two topics, like understand your data and Azure Data Services. These two topics are not part of the Microsoft official document, but they are really important for designing and implementing the storage in your Azure, and these are easy ones. So first, understand your data. As we all aware that data comes in different shapes and size, so no single solution fits all the data. Hence, to decide the optimal storage solution for our data, we need to understand the data first. So need to understand the data first means like we need to know what type of our data is it, like whether it's a structured data, semi-structured data, or unstructured data, and how we will use this data. Basically, what kind of operations we're going to perform on it, what kind of performance we want, like the latency and throughput and all those kind of things. So that's once we have the better understanding of our data requirement, then we can choose the data store accordingly. So based on our requirement, we should start considering which storage model is best suited for us. And here are some general considerations. For example, like relational database management system, for that Azure have Azure SQL database, Azure database for MySQL, Azure database for PostgreSQL, and Azure database for MariaDB. So if you have a OLTP kind of environment, I'll recommend use Azure SQL database. And the next data types is like key value store, which is basically a NoSQL kind of database. So for that, there are 3 services: Azure Cosmos DB API, Azure Cache for Redis, and Azure Table Storage, which is a part of Azure Storage account too. And the other NoSQL data type database is document database, and for that Azure Cosmos DB SQL API is enough, and also Azure Cosmos MongoDB API will be good. The other category is graph databases. That's also a part of NoSQL. So for that, mainly 2 services. The first one is the Azure Cosmos DB Graph API, and the second one is SQL Server. Like you can store the data in SQL Server too. For data analytics, Azure Synapse Analytics is a good is the best option, and the Azure Data Lake Storage Gen 2, which is part of Azure Storage account, and we will look into that shortly. Column family database. If your requirements are column family database, which is also a NoSQL, then go for Azure Cosmos DB Cassandra API and HBase in HD Insights. For search engine kind of databases, Azure Search is available, time series, Azure time series insights, and for object storage, Azure blob storage, and we can also use Azure Data Lake Gen 2. They both part of Azure storage account. And shared files, for example, like your NAS drives, SMB protocols, Azure files um, is the service available, and this is also part of Azure storage account. And before I start Azure storage account, and I just want to mention, like, there are always like couple of questions in exams which come very straight from this from Azure Data Store Services. Like, they will tell you, okay, you have this kind of data, so which service you should use. It's always like a one or two questions in the exam, so it's good to know aware about all these services and where we can use these services for different data types. Okay, as we saw in the last slide, that Azure provide many ways to store your data, but uh, Azure selected 4 data services: Azure Blob, Azure Files, Azure Queues, and Azure Tables uh, together, and they place it in under a service named Azure Storage. And in that service, we will be mostly, like in this for DP203, uh, we will be using Azure Data Lake Gen 2, which is nothing, which is like just built on top of blob storage. And if you need more information about it, I'm going to provide a link in the description where it explains what is Azure Data Lake Storage Gen 2, what capabilities it have more than Azure Blob, and and a demo like how to create and all those stuff. In today's video, we will cover the following topics. The first one is designing an Azure Data Lake solution that will be on Azure Data Lake Gen 2. Recommended file types for the storage in Data Lake, recommended file types for analytical queries, designing the data lake for efficient querying, and the last is designing the folder structure that represent the different levels of data transformation. So when we are designing a data lake, there are various considerations need to be accounted, such as data lake structure, which means how we want to organize the data, file types, file formats, and also we need to think about the high availability and disaster recovery scenarios too. And the last piece is the data security. Data security is like how we going to govern our data lake data. This section I won't be covering in this video. It will be covered in the security section of this video series. So this diagrams give you a high level of structure of data lake, which tells you the different layers of it. So you can look at this, like the first layer is the storage account, second is file system, and the last one is Jones directories and files. Basically, this is like a folder hierarchy structure. We're going to look into all of them in detail. First, we'll start with the storage account. There are so many properties that need to be configured while creating an Azure storage account. The first one is the performance tier. Performance, there are 2 types of performance tiers: standard and premium. Standard, which is recommended for most of the scenarios. Premium, it's recommended for scenarios where we require low latency. Replications, it's used for high availability and disaster recovery, which we'll see in the upcoming slides in more details. Access tier, how we want to access it. So there are 2 types of it: hot and cold. Hot means it's like a frequent access and day-to-day usage. Cold is like an infrequent access for backup scenarios and archive and all those kind of things. Connectivity method is like how we want to connect our storage account, either publicly on a public network, private network. Depending on your requirement, we have to select our connectivity method. Secure transfer required. is a property which enhances the security of our storage account by allowing only those REST API requests which are HTTPS. So if somebody trying to request our storage account using HTTP, they won't be able to access it. And the last property is hierarchical namespace. That's escalate our big data analytics workloads and enable file level access. So let's look into the replication. Replication is very important for high availability and disaster recovery from disaster recovery perspective. So there are only 4 types of replication methods available: locally redundant, zone redundant, geo-zone redundant storage. So locally redundant storage, it's happened within the same data centers. There will be synchronously 3 copies will be created. So if any disk failure or hardware failure, these kind of situations happen, uh, this replication will take care of it. And this is like recommended for those applications which are not criticals or anything which we can build again very fast. And it provides durability of 11 nines. Zone redundant storage application is basically synchronously 3 copies are created in availability uh, zones, and if a data center goes down, still a storage account will be there because other data centers are working. Uh, this is also for those applications which work uh, or for the storage which are applications which are specific to a region. Uh, if one data center goes down, we still be able to access it through the other zone. But the whole whole region goes down, uh, then we won't be able to access the storage account. For that, we need to use GRS, geo redundant storage application. So geo redundant storage application is basically create synchronously 3 copies as a local redundant storage and asynchronous copy to the secondary region of our OS, and there synchronously again create 3 copies of it. So in this case, if our primary region goes down, we still be able to access the data through secondary region. This is like for the critical applications. And geo-zone redundant storage is basically uh, everything which we have in GRS, but instead of LRS, in our primary zone we use JRS. So synchronously zone redundant storage are created in all availability zones, and then asynchronously data is copied to the secondary region, and they're synchronously copied again using LRS within the same data center. Yeah. So like one thing you might have noticed is like RA. So here it says RAGJRS, and this is RAGRS. So that is read-only access to the secondary region. So by default, it's not active. So either user or Microsoft has to activate it. And once read-only access is activated, we can access this data in all the times, including if a disaster, if an actual disaster happened. File system. File system basically is like a, I'll say, it's the container. It's another way. Like if you go to the Azure storage account, the storage account is the main, and the second layer is the container. I call it file system because it works like that. So container is basically that holds the hierarchy of our folders and files. We'll see both, like we see all these things in the demo. The next thing comes like zone directories and files. Basically, zone is the root level of the folder hierarchy, and after that we'll have various directories depending on like a source of the data, data type, and all those kind of things, and our partitioning and all those factors. But this picture give you like a very clear understanding of things like how we want to do. So storage account is our main thing, file system, or like this should be the container, and in this layer, like basically we'll create folders. So this will be a raw folder, then curated folder, and in that folder, like in raw, we could have different subject areas and then different data sources. Then after that, depending on partitioning, we can have further folders. So Zone basically, as I mentioned, it's the root level folder hierarchy, and um, it can be of many types, but these are the mains which should be there. But it's not like a exhaustive. You can have more than these. So there will be mainly, but all these, like these files can cover all the zones. So one is the raw, clean, curated, sensitive, and laboratory. Raw, which is also known as bronze zone, here is the location where the raw data lands from the various applications, and this should be immutable. That means like once data landed, it should be locked down head and only have read-only permission, so users won't be able to manipulate the data. And this zone we can further organize based on folders per application or something like that. Next is the clean zone. Clean zone next is the next zone, which is also called, in some places you might, some people call it staging, or it could be very, but like there is no hard and fast rule for the naming conventions. But clean basically is where we remove the unnecessary fields, records, do some kind of like aggregations, joins, and all those. So here is basically we apply the rules and enrich the data. Curated is basically is the conception layer where we do the advanced analytics or data science kind of things. Sensitive is a zone where we lens all the sensitive data, or you can say classified data, which have personal PIA, personal identification information, and laboratory, where data analyst or scientist can play with the data until like it's productionized, or they I won't say play, but like basically you can say like they developed their analysis here, and after that you can productionize it. Okay, so next is the directory or the folder. So zone, as I mentioned, is the root, but after that you need to create directories. So you can see that here different folder structures are there, like what the subject area, what's the data source, year, date, month, date, formats. It's not like there is no uh, hard rule around it that you have to follow this. It could be based on your requirements or what you want to achieve. So for folders or directory, there has to be few things which we need to keep in mind. First, it need to be human readable, understandable, consistent naming conventions. And each folder should have files of the same schema and format. So like for example, in this day folder, we should not have different types of files. We should have same schema file and types or format. And to optimize the performance of our queries, this need to be aligned with the partitioning strategies. We will see the partitioning strategies in upcoming videos, but directories need to be aligned with the partitioning strategies. And the last is the file format and the file size. So Parquet has been like the most popular size in the lake, but it not necessarily is the only choice. It can depend on like situations and which zone you are. So for example, in raw zone, you can have JSON, CSV, XML, or even like Parquet too. Non-raw zones like any columnar format, especially Parquet or Delta Lake, are the good choice. Um, and the other thing, like which I want to mention, is about the file size. So Lake work well if we are if the file sizes are big. If we have very small file sizes, like the performance will be horrible. So one scenario could be, let's say if we are using Lake as a storage for our stream analytics, in that case, like there will be very small files, and then we need to compress them. So like when we are querying them, like it's bigger in size, and we are able to write we are able to get the optimal performance out of it. So the idea is to avoid like a small file sizes in data lake. Some general information about the Azure Data Lake Gen 2. The first one is the usage. So the usage is like it's used in the big data analytics world, and storage, and it used as a storage for various compute services in Azure, such as Azure Synapse Analytics, Azure Databricks, Azure Stream Analytics, Azure HD Insights. And to query data, this is a driver which is used Azure blobs file system. And the last piece about the performance, as we so there are like two things which we need to keep in mind. One is the structure of your data, which we were talking about. Like it need to be in proper folder structures and proper file formats and file size. Otherwise, like it query will be, or you can say the performance will be not that good. So we need to keep those things in my mind, like to have a proper folder structures, file types. And the other thing is, like, if you are ingesting data directly into Azure Data Lake Gen 2 through an application or something, then we need to keep few things in mind, like what's the source hardware, how it looks like, is it strong enough to ingest a good amount of data. And second is like network connectivity. Like there could be like in some situations the connectivity could be slow, so keep these things in mind to optimize the performance. Okay, yeah, so now let's jump to the demo. Perfect. So I have already created like a storage account with the name Data Tech CRM, and as you can see, we have our data lake, storage, file services. These they all four together are part of the storage account. So let's look at the data lake storage. So as you open it, like in the container, so data lake tech CRM is the storage account, and these are the zones we have in there. So you can look at the clean zone, curated, lab, raw, sensitive. So based on like it's the root of all the our folder hierarchies. If you go into raw, then like types, data types, or I won't say data type, like data sources. So one is the sales data, other is the customer data, and depending on your scenario, you can have other things. Then next, in your directory, like in sales also, it could be of multiple types, let's say online sale, point of sale. So based on that, you can have another folder hierarchy. And then this is like what comes from partitioning. Like now we are partitioning the data based on the year, month, and day. So I know there is like no data, but look at this. This is the zone, this is the directory structure. But in partitioning, you will see that this top, like year, this is like a classic example of date, month, and year. These are the classic example for partitioning the data. And so this is like your container, then zone, your files, and folder structure is there. So this is like I already created this, so I want to show you how the directories and zone, like how can you create zone directories and folders. Now I want to show you if you want to create I want to show you the storage account properties. So click on create. Okay, so these are the subscription and the source groups are the general information which we need to provide. And after that, storage account, like you give the name to the storage account. Let's give it data tech CRM2. And after that, this is the reason, and this is the like prime reason. There will be a secondary reason associated to it which we don't know, like That's Microsoft take care of it. Performance, standard, and primary, which we discussed, like standard is for most scenarios, and this is for Data Lake Gen V2 account. But primary, if you want to go for low latency kind of scenarios, and redundancy, which we talk about, there are like 4 types of redundancy, so you can pick whatever redundancy you want for your storage account. Let's do this. Then in advanced, so this is the secure transfer I was talking about. So this is by default selected, so don't change it, but this is the main, like one of the main things. And access tiers, hot and cold, how you want to access it. And this is really important, like Data Lake for Data Lake Gen 2, we have to enable the hierarchy namespace. If we don't enable the hierarchy namespace, we won't be able to get the folder structures. It will be like a virtual directory, so, and then we won't be able to get all the functionalities of Azure Data Lake Gen 2. It will work as a blob storage if we don't check this. Okay, networking, this is the thing we discussed, like how we want to connect to our storage account through public, private, or public endpoint with selected. Data protections, like if you want blob storage and all those, soft deletes, and for containers and file shares and all those. So it's by default, I haven't changed anything. There are like few things. As soon as we select the hierarchy namespace, like these options, some options are grayed out. So Azure Data Lake Gen 2 is built on top of Azure Blob, but it not have all the features. Some features of Blob still is only available in Blob, not in Azure Data Lake. And from encryption point of view, as Microsoft already or Azure already encrypt your data with so that's that's a good point for our data security perspective. And that's it. Like after this, like do the validation, you can check all those things, and if you click on create, it will create the like storage account, and there, once you have the storage account, it will look like this. Like go to your like storage explorer and look at your containers, and there, like you can go to raw. You can access this way, or even you can go to overview, and you can access directly from here too. So that's all for this video, and I have another video on Azure Data Lake Gen 2 which talks specifically what it is and all those kind of things. So I'm going to provide the link of that link in the description, but the focus of this video was to how to design it, what things need to keep in mind like while designing, and to understand the properties and all those kind of things. And this is like really important from Azure DP-203 perspective. In today's video, we will try to understand the Azure Cosmos DB storage. This picture best describes the Azure Cosmos DB. It is a fully managed database service with turnkey global distribution and transparent multi-master application. It has single-digit latency and high throughput, so it's best fit for the applications which are highly responsive and always available, such as web, mobile, or gaming, etc. And to ingest data into Azure Cosmos DB, it can be done through the application and other APIs, etc. And in this picture, you can see like data is replicated globally across is replicated globally. So this can be easily achieved by just a turnkey feature, which we will see in the demo. Like it's very easy. You just click on something and it will replicate there. And Azure Cosmos DB supports multiple APIs, they are highlighted at the top: SQL, MongoDB, Gremlin, Cassandra, Table. And these APIs are used for different types of NoSQL databases. These are key value. So key value is used by Table, column family is used by Cassandra, documents used by SQL and MongoDB, and graph is for Grammarly. And these are the some other features of Azure Cosmos DB, like guaranteed speed, which we guaranteed speed at any scale, which we already talk about, like single digit latency and high throughput. Simplified application development, it integrates well with the other applications. Mission critical ready, the turnkey or like replication factors make it mission critical ready in any situation, and fully managed and cost effective. So this is the structure of Azure Cosmos DB account. So we'll start from the left. So when you create an Azure Cosmos DB account, it will have a database account, which will be the top hierarchy. Then it will have multiple databases, and multiple databases will have container objects, and in containers you will have various other objects like store procedure, user defined triggers, and all those kind of things. And containers, depending on which API you're using, container will be categorized accordingly. So if we are using, let's say, SQL and MongoDB, it will be collection. So it will be collection. If we're using table, it will be the table. If you're using graph, and so on. And same thing goes with the items too. If it's depending on your Cosmos API, the item will be realized as a document, row, node, and age. So document will be for SQL and MongoDB, row for the tables, node for the columnars, and edge for the graph. So next thing is like I want to talk about is partitioning. So before we start, there will going to be a separate video on partitioning for all Azure data storage services, including Cosmos DB. But we need this to create containers in Azure Cosmos DB. That's why we are discussing here. So as I mentioned, like we need this while creating a container, so it's critical. So let's try to understand how partitioning works in Azure Cosmos DB. The partitioning basically is the items in the container are logically divided. Items in the container are divided into distinct subsets. We call them logical partitions. And once data, so you can see there, like in your data, let's say in your database, you have two containers. One container is partitioned using partition key city. Other one is used by airport. So for each city, the data is this. These are called logical partitions, and same goes for the airport. These are called logical partitions. But once like logical partitioning is done, the items are, once logical partitioning is done, it's the Cosmos DB data engine, database engine that divides to which physical partition they will lend. So as a user, we just care of the partition key, but the Azure Cosmos DB engine will take care of this. So from this diagram, we can see London, New York, Paris will fall into this physical partition. Rome goes here, and the airport AMS goes into this partition, and LAX and C goes into this physical partition. So one physical partition can have multiple logical partitions in it. Next is the shared and dedicated throughput. So I'll show in the demo. There it will be easy to understand and easy to grab. So let's jump into the demo, and we'll come back here to this PowerPoint to cover our last slide, which is like showing the I'll say the like trade-offs of different consistencies, and I'll explain that in demo only. So let's go. So I've already created a database account in Cosmos DB, but I'll show you, because it takes like approximately 10 minutes to create an account. So I'll show you how simple it is. Click on create button, search for Azure Cosmos DB and click on the create button, and based on what type of data you're going to handle, you can pick whatever data API for that. So you have to pick the API according to your database you're going to use. So click on, let's say we're going to start with SQL, click on create. Then we have to pick the resource group, give the name. So let's give it test. Oh, it needs to be data tech test 2, or like Cosmos DB 2. Then pick the reason, whatever based on your location. So I'm at East ES2, and after that, like, you go here. This is the global distribution which I was talking about. So hey, like you can enable these global distribution features from here, or even if we don't, like, we can also change these settings later in the account, which I want to show you guys, and that is also known as turnkey global distribution. And this is like this is critical from high availability and disaster recovery, as you guys are remember from Azure Data Lake Gen 2, there we have like 4 options, but here it's like it give you more graphical way. Like you can do it from here too, but like I'll show you in the account like how they, like, you can do it from the graphical way. Rest of the things you can leave it as it is and click on review, and like click here, it will validate and it will show you how much time like it will need. So it says 10 minutes. If you click on this, like in 10 minutes it will be created. I've already created, so I'll go back to my created account. Okay, so you can click on the Data Explorer. I want to show you so this is our database account. Now we have to create a new container, so we click on this. So it says like if you remember the structure, if you go back to the slide, the first thing is the database account, which we already created. This is the database account name, and the next thing will be the database and the containers. I've already created a database named OLTP, but you want to create a new one, you can create a new one too. And then container ID, what container you want, partition key, and all those kind of things. But let's create a new container. Sorry, let's go here and create a new container. Click on Data Explorer, new container. I'll give it OLAP name. And the other thing which I mentioned, like I will show you through shared throughput, across shared and dedicated throughput. So if you see here, like when I'm creating a new database, and this option is by default, so whatever throughput this database will have will be shared by all the containers within it. And a database can have multiple containers. So let's say if it has 1000 throughput and it have 5 containers in it, all these containers will have 200 throughput to it. So if we don't want to share it, we just want to create a dedicated throughput to our container, just uncheck it, give it a container name. Let's give it a families. Sorry, let's correct the spelling. Partition key, which I mentioned. This is the logical partition key which we are doing, but like in our future videos we'll see like what things we need to consider even while creating a like a logical partition key. But like this is a logical partition key, and then Azure Cosmos DB engine will create a physical partition key. And here we can this is a dedicated container throughput. If you click on manual, you can give whatever number you want. And if you want, like, if you don't want manual, you want to share it at the database level, you can click it here. So depending on like your requirement, or what kind, yeah, depending on your requirement, you can share the throughput across all the containers, or you can give it to the dedicated. I'll click it share, and then you can click OK. It take a couple of it's fast, it won't take that long, and once this step is done, you will see another container with the name OLAP. Sorry, not container, oh, like another database with name OLAP. Let me close this, go here, the Explorer. See, so we have, this is a database account, these are databases. So a database account can have multiple databases, OLP, OLTP, and if you expand this, you will see families. This is a container, and if you expand this, so I've already created one, but this is a container. You go here, and items, like it's a SQL, like you can query the data in these items using this SQL, but at this moment there is nothing. Let's load it. So if we go back in Explorer, look at this. So you see there are like two records are here. Let me make it more visible. So these are the two records, which two documents which we uploaded here, and you can query this like from this too. You can copy, paste, Control C, and close this. Item. Not a new, like you can copy as a new notebook. You can write it. 1 second. Yeah, here. My bad. Sorry. No, let me close this. So you can query it as a SQL too. Just give me 1 second. Go to Data Explorer, OLAP, families, item, and yeah, you click on this, and then if you run this, you will see the document. You will see the content of the document. Perfect. So now we have covered the shared throughput and others. Now let's look at the like a turnkey feature here. So if I click on this replicated data global thing, so this was the thing I was telling at that point, like you can like do a global distribution just with a single click. They make it that simple. So if I click on, let's say I'm in East US, but if I want to replicate it to anywhere in this world, like I can simply go there and click on that. Like if I want to go to Japan West, I can click on this. If I want to go to Australia, I can India, Africa, Brazil, wherever I want, like I can just with a single click I can do that. But so that's like one thing which make our life easy, like with a single turnkey things are available. That's one thing. Second is like we need to keep in mind, like our main reason is like the read reason, and the other reasons which are we clicking are read reasons at this point, because we haven't enabled our read write. So if you click on enable, like I'm just like not going to do that because it takes times, but if you enable, they both become read write. You can see it here. So both become read and write, and in that scenario, if any disaster happens, Azure automatically, let's say if East US goes down, it automatically copy our storage will from center US will start working automatically. Okay, That's one thing we need to keep. So if it's like a read option when we are globally replicating, you don't have to worry about anything. But if, let's say, if it's not read option, it's something like this. You just have only one write reason and others are the read reason. In that case, you, if any failure happens, like you have to take care, like you have to use either automatic failover or manual failover. So in manual failover, like I know I have only two reasons, but let's say if I have East US, Central US, and West US, and they both are read, so I can select one and make it as soon as trigger happen or anything goes wrong, it will become my right reason. And if I go back here and in automatic, like I simply turn it on, in that case, like Azure will make the decision on based on Azure will make a decision like, okay, if one reason goes down, which other read reason need to be enabled for Cosmos DB. And then the last topic I want to talk about is the consistency. So consistency is you will be wondering what is consistency here. So here consistency is like a uniformity of the data in the distributed database. So because we are replicating the data between different data centers through that turnkey options, but these data centers these are separated hundreds or thousands miles away from each other. So in that case, the consistency could not be same if somebody is writing at the same time and other person want to read it. So for that, there are like 5 consistency options are available. So we'll start with the strong. So strong consistency is the strictest model where data written using this consistency is synchronously replicated in every data centers. It's supposed to, like, in every replica basically. And the second one is the bound stainless. In this, like, data is replicated asynchronously based on a predetermined window or I'll say number of writes. So what happened in this one, like it is you can so in this one, like anything comes under the window will be strongly, it will be like have the same consistency, but anything. So that's this session is a unique or by default consistency, which is basically client centric, not the data centric, in which like a person in the same session will have the consistency while the person in another session won't have the consistency. Consistency prefix is basically if a write was performed in an order ABC, then client see either AB or ABC, but it will never be something in the AC or BAC or in some like I'll say like it has to be in an order. It can't be unordered. And the last one, the eventually, which is like the weakest, and in this one, like consistency will not be there. Like you might read something which is not written, like things won't be in an order, and this is the weakest consistency. So the trade-off all these things is, if you want so these are the trade-off of Azure Cosmos DB consistency. If you want a strong consistent, like anything here, there will be strong consistency, but it will have a high latency, lower throughput, while this will have weaker consistency but lower latency and higher throughput. So depending on your requirements, because this is for the replica or the places where we replicating our copy, it's for that. So depending on your requirements, you can go whatever consistency fits well with your requirements. Thank you. That's all for this video. Stay tuned for our next video. Have a good one. Today we're going to talk about introduction of Azure Synapse Analytics. It's going to be part of like a web series where we will do uh, advanced stuff, like for example, building pipelines, creating data flows, and other machine learning and other kinds of stuff in Azure Synapse Analytics. But in this video, it's an introduction video. So without further ado, let's start. So before we go into the details of Azure Synapse Analytics, let's take a look how Azure was before Synapse Analytics. And this is the like high level diagram of how data engineering looks in Azure before Azure Synapse Analytics. And here we can see that like to move data from various sources to the sync, or you can say uh, letting it reach to the like business users or making a visualization. There are many services involved, such as like Data Factory, Databricks, and SQL Data Warehouse, and those kind of stuff. So it have like a lot of moving elements to it. So now let's see how things changed after the introduction of Azure Synapse Analytics. So now you can see what's the data engineering looks in Azure world after the Synapse Analytics introduction. Here we can see only one service is required for moving the data from various sources to consumed by business users or data scientists or other kind of data users. Now you can like this picture shows that like Azure Synapse Analytics bring a lot of benefits for a data engineer or anybody who was using like those various services in the Azure world. The first thing is like there are like less services, so we have less things to maintain, monitor, even learn. So it makes like life of data users very easy. And the second is like cost effective, as we are paying only for one service, which is like very cheap compared to paying for like multiple services. So now let's take a look into what is Azure Synapse Analytics. So in theory, it's a service which brings data and relational database together. It gives user the power to use SQL or Spark at scale on data stored in the data lake or data warehouse. That's like a theoretical uh, language for Azure Synapse Analytics, but as a user, I'll say like there are like four things which we have to focus. The first one is the Snap Studio. So Snap Studio, it's a unified user interface where we can build all our data solutions, and we will have a tour of it or see how it looks in few minutes in demo. And the second thing is like you can look at the analytics runtime. So we as a user can use either SQL or Spark based on our preference. Both are available in Synapse Analytics, so that's a pretty cool feature. And SQL is available in like two resource models. One is like serverless, which where we don't want to maintain our pools, and the other one is the dedicated SQL pool. And Spark is available only in like dedicated, or we can provision according to our need. And the last thing we have to like one more thing we have to focus is like it have built-in data integration. So whenever we create a workspace in Azure Synapse Analytics, it comes with like linked data lake, which we'll see in few minutes. And also we can ingest data from more than 90 plus sources. And the last thing is it have data flow, which which is very helpful in creating pipelines or doing a lot of like data manipulations and transformations for those people who don't know who don't know how to code. So let's do some hands-on practice on it. So the first thing is we have to go to the portal. Where's the portal? Here's the portal. Okay. This is okay. Sorry. Yeah, let me click here. So the first step is to log in into the Microsoft Azure portal, and If you don't have an account, don't worry, you can create an account. It comes with $260 free credit, and which you have to use within a month. So I highly recommend like sign up with that and play around with uh, Azure Synapse Analytics or any other services in which you are interested without paying. And once like you're comfortable, you can upgrade yourself, or or like if it's your workplace, you don't have to worry about, your company is already paying. So the first step is to search for the Azure Synapse Analytics. So like if you look at this section of the, let me highlight this section which is highlighted. uh, this is like all my recent search. So if you're doing it for the first time, probably you don't have anything, but if you're looking for Azure Synapse Analytics, you type in and you will get Azure Synapse Analytics. You click on this. I already created a workspace to save the time for our to save our time, because like it take a couple of minutes to deploy the workspace. So I already created, but still I'll show you how to create a workspace. That's the step one. When we want to play with the, when we want to do things on this, like we need a workspace. So we click on new. Okay, and once you click on new, oh sorry, my bad, I double clicked. But when you click on new, this window pops up, and in this window you have to pick your subscription. As we are using the free trial, we uh, that's the only subscription, but if you have other, you can pick whatever, like whatever works for you. The second thing is we have to pick the resource group. uh, Resource group is basically a container which hold all related resources together. And the, then you give the workspace name. So workspace name of your Synapse workspace, and it has to be globally unique, pretty much like our username in various applications. For example, Gmail, like you can't, like two people can't have the same Gmail name. The next piece is picking the reason. So you can pick wherever you want. I'm on, and for example, I'm in North America East, so I'll pick that and you can pick according to your location. So I can see East US2, I can pick that. And uh, then the last piece is linking your data lake storage gen 2 to our workspace. So if you already have a data lake, you can use that. If you don't, like, you can create a new one. So a bit about data lake. It's like a blob storage uh, which is compatible with Hadoop. And if you want to know more about it, I already have another video. For that video, I'll provide the link in the description. You can go and check it out. And so to connect to a data lake storage, we just need account name and the file system name. So account name is whatever is the name of your storage, and file system is basically the root or the main folder which will going to contain other folders and file for you. So as I say, already created, but if you want, you can create new one. And after that, you don't have to keep other things to the default. Click on review and create. You will have your workspace ready. After that, you will, like, after a couple of minutes, like once it's deployed, you will see this. And then you can click on your workspace and scroll down and click on open Synapse Studio. I already open it. Like it's fast, it doesn't take time, but you can do that. And here, like, one thing you need to keep in mind, like once you're doing it for the first time, it asks you to accept the cookies, so we have to accept it. Let me close this. I'll go back to our old one. So let's have a quick tour of how Snap Studio uh, look. So as you can see, this is our landing page where it tells like what new things you can do it. Like you can ingest data, explore, visualize, and do other stuff. So basically you can build whole pipeline or whole data solution within one place. So the first component is the data. So data is basically uh, here you it's a place where you will see all the data which either are linked or you created. So when I say you created means like database you create, or linked is like to whatever it's getting. So by default, as I mentioned earlier, it's linked to the Azure Data Lake Gen 2 when we are creating the workspace. So that's here, and other things you will see here in some time, like our like a data warehouse, or we can link it to the other like sources too. The next piece is the develop. So it here we develop our code and queries for our data pipelines or all or any transformation. The next piece is integrate. Integrate is the place where we create pipelines or do data flow kind of thing. So if you click on this, you will see you can create a pipeline and you can copy data too. So basically this functionality is when you have big data coming from a source and you want to copy it to one of your, let's say, to your data like Gen 2 or one of your data warehouse created within Synapse Analytics. So you can do that too. And the last and second last is the monitor, where you monitor all your jobs. Uh, and the last piece is the manage. So manage, it's basically, as the name says, is to manage all the resources related to your workspace, such as like pool, link services, and triggers, access control, and you can even connect this to the GitHub. So we will see all these things, some things in this video, but some things in the future videos. So the first thing we want to look into is the Spark pool and the SQL pool. So as soon as, like, once you open your Snap Studio, click on Manage, you will come here. So let's start with Spark SQL pool. So SQL pool, basically, whenever we create the workspace, it comes with a default SQL pool name built in, and which is which is serverless. So what that means, like, we don't have to maintain it, and it can scale as per our requirement. So let's say if we're running a big query and we don't have to worry about the resources, it will scale automatically. And the next thing the SQL pool is available is, like, we can create a dedicated SQL pool. So for that, like, it's very easy. Click on new, provide the name of the pool, and depending on like what kind of performance you want. So, and it's related to your so performance, like if it's available in your a reason and how much you want. So that's also related, but basically performance level is like, if you want a high performance level thing, you can expand this, or you can like just slide it down, like based on your requirement. And as you can see, once you increase, I know like this is not available in my reason, but you can see we can get um, like we can get a high performance SQL pool too, but it costs a lot. So it's a demo, so we'll go to the base SQL performance level and give a name. Uh, I already created, but feel free to give whatever name here. We don't have any restrictions, such as like global or something. So let me cancel. Like, I already created this. You can see that dedicated tech SQL pool. And one thing we need to keep in mind, like, once we created a dedicated SQL pool, it is associated with the SQL database. So as soon as we create a dedicated SQL pool, we'll see a database with the same name in our data section. So if we go here, and I know like it says 0, but if we refresh this and let's expand, see, boom, it's the same name of our uh, dedicated SQL pool. So basically, whenever we're creating a dedicated SQL pool, it means we're creating a database for us. So now, at this moment, we have two sources related to this workspace. One is this database, other one is the link data lake. Okay, one is database, other one is the data lake. Let's go to the manage and create talk about the Apache Spark pool. So I already created I already created a Spark pool to save time, but you can create a new one. Just click on it, very simple, give the name, and then we have to tell like what node size we want, whether we want like auto scale to be enabled or not, how many nodes we want, and like the node size and number of nodes will impact your cost. So choose wisely. If you just practicing or doing demo kind, like just learning, so I'll say go for the lowest one. Like for example, like you can give whatever name you want, but in the node size always go for the small one if you are learning and doing anything. But in case of like your organization, you have to pick based on your requirements. And auto scale also, like you can enable or disable auto scale, like helps like to scale uh, your performance automatically. You don't have to worry about it. And nodes you can pick accordingly. I already created it, so I'll cancel it. Okay, perfect. Now let's do some development here. Okay, so as you can see, we have a database and we have a we have a database and we have uh, a data lake. And it's Data Lake Gen 2, as I mentioned, which is a blob storage compatible with Hadoop file system. It's like basically a file system. So, but so far we don't have any data. So let's start with uploading some data. So I'll go 1 second. We go to my desktop. Okay, well, sorry, my bad. So we just upload this New York's trip file. This is like an open data sets available. Open data sets are basically data sets which are available for public to use and perform to do stuff like to do analytics or that kind of things which are available from government. So let's upload this data first. So we go there, click on this, upload. So yeah, so upload is done now. So we have some data now. So we can do some queries and all those stuff. So I already like wrote the queries, which is available in my GitHub. I'm going to provide the link of my GitHub repo in the description, so you can use the same. So let's start with the SQL demo. Okay, let's copy paste this and I explain like what we're doing there, so you know what's going on. Let's go back to our workspace, click on develop. Let's do a new script. Oh, sorry. Close this. New SQL script. And perfect. So here you can see it's a very straightforward query, like nothing crazy. It's a simple select statement where we're just looking at the top 100 records from this Parquet file. So you can see we like in connect to, we are using built-in SQL pool. If you want, you can choose the dedicated one. Let's start with the built-in. And here, like you can like in this interface, you can write whatever SQL query you want. Here we going to show the first 100 records from those Parquet files, and I think this capability is available in Parquet, JSON, CSV, or any text file, any flat files. So let's run this. Select all, run. Oh, sorry, my bad. I need to change the, 1 second, let me go. So here you see like the location. I had the location from my old code. Let's go there very quickly. So go to this. So the data text storage is the name. So we go there, we click on this. And don't be afraid or like feel okay, well, we're getting error. I always say like getting errors while running the code is the good thing. So you get to know that like what kind of problems you can face when you're doing different kind of things. Uh, okay, we're getting the same error. It says data text storage doesn't exist. Give me 1 second. Let me go here. This is our data tech workspace. Let's go to the resource, do some debugging. We go our resource group. So we have SQL pools. What is data text storage? Did I spell it wrong? Let me check. Oh, another problem. So I'll tell you why. I copy paste and fix it. Oh, sorry. Let's create a new one. Copy paste. So the name and change it to SQL. Make it more interactive. So it's data tech lake storage, which we already fixed, but the folder name is data. This time it should work. Boom. Go here, copy this, Control A, delete, Control V, done. Fingers crossed. Oh, perfect. If you expand, click on here, so you can see the data here and different data types. So that's for the SQL query. Now let's do some Parquet, some stuff with Spark. We go again, like we already in develop, and we create a new notebook, and we're going to write some Spark code. So I already have the code. Let me go there, and as I mentioned, I'm going to give you the link to this you can play with, and just be like as you saw, like just make sure like your names of your like storage and folders are properly aligned, otherwise you will get an error. And let me fix this very quickly. So users will be replaced by data, and this will be perfect. Now we can copy. Now let's copy the whole code, and I'll explain what's we doing here. Control C. Let's go to here. Paste. And you see like we are getting a warning that we haven't selected a Spark pool, so we can select a Spark pool. That warning will go. So here we doing a very simple Spark code. So like look, I'll explain one by one. So in the line number 4, we just reading those Parquet file from data lake, then we printing the schema. So schema will like always, this is like one of the good practice I always do whenever we reading the data. So the first thing you want to explore the data, like what's in it, what kind of data fields are in there, what's their data type, then display like first 10, then create a database. So till here like it's easy and simple. We reading the data, printing it, and displaying the top 10, and after that we will creating a Spark database named New York Taxi. So that like once this is executed, you will see this New York Taxi in your data tab here, sorry, in workspace, along with your along with your database. And then we doing the repartitioning. Then this with me make it more more readable. Okay, so then we just creating a New York, like first we creating a database New York if it doesn't exist, and here's one, and then we just repartitioning and saving the whole data as it is in this table named trip. So one thing I want to mention here, like at line number 9, if you don't create a database, Spark have a default database name with name default. So if you don't create it, like it will store the table in the default database, and after that we just doing a count. That's another good practice. So that's I'll say like one other good exploratory or data quality to check how many records we have. And after that, in this is a straight SQL query. We are like just doing an aggregate on the trip table. So here you see like on the passenger count dimensions, we aggregating the sum and the average of trip distance miles, and then of, and this where clause says like any trip distance miles which are passenger count which is greater than 0, just simply aggregate, like sum the trip distance mile or average it based on the passenger count. So you can see group by and then we saving it. So it's pretty straightforward. If you guys have any questions, feel free to ask me in comments, and I'm going to share this code in um, uh, share this code in my GitHub repo, and you will find the link in the description. So let me select this and run it. So run all is basically, so sorry, I went to the run all. So run all is like if you have multiple notebooks. But here we have only one. Sorry, we'll just click here, Control A again, like this. While like it takes some time, so based on like how much data it is, how much cores you're using. In the meantime, we can, because like it start the set, and you can see it start the sessions, and depending on your resources, how big is your query, it can take time. In the meantime, we can we can create a table in our we can look at the our dedicated SQL pool and create a table in it. So let's go to the go data. Nope, sorry. Go to our develop again. Click on SQL script, and let me copy the code for it too. So this time we're creating a table. Let's copy this. So this time we will not use the built-in, we will use the dedicated SQL pool. And here you can see we are creating a table which pretty standard format of writing. This is a very like a standard SQL query to create table, schema name, and the table name, and then the different fields and their data types and whether they are like null or not. And here you will see like with what kind of distribution you want, basically by default it's round robin, but there are like a couple of others, hash and flat, which we'll talk in future videos, like don't worry for now. And then we just copying the data from this open data source of Microsoft and storing it in here. So let's run this. Let's just create it. Query is done successfully. Let's go and check. We expand our database and tables. Perfect. Boom. We have our table. So DB is the schema name and geography is the table name. And if you currently don't have data, it's just basically a table with no data, or like you can say skeleton of table. Now let's copy some data to it. Perfect. And now if we go here and do select top 100, now you can see this. So we have data in it, and This is the top 100 records. So that's how you use, like, you can use like dedicated SQL pool or SQL or like serverless SQL pool interchangeably, but like that's how I want to show you, like you can do the like all normal SQL stuff which we do for which we do in our like all traditional data warehouses like Microsoft SQL Server, MySQL, and all those stuff. And the notebook, let's take a look like what's going on with Spark. So command is executed. Let's do. Oh, sorry. Let me delete this. Sorry, there was an error. I didn't say. It's in progress, and if you want, like you can monitor that too. But let's get finished. Once this the job finish, you will see like another Spark. You will see a database name New York Taxi and Spark in front. That's like with a Spark symbol. Like here, this is a symbol of a database. There you will see a Spark symbol, and that means like it's a Spark table. Which basically here it looked like okay, it's pretty much like a database, but it's not. So you can see we executed it successfully, and let's refresh this. Sorry, my bad. Like I need to. So now you see a folder where like this is basically stored in data lake, but you will see that in your workspace too. Just give me a moment, like refresh again. Sometimes it takes times. Perfect. Ooh. So here you can see now like New York Taxi, which we created, and it will have two tables. One is name trip, the other one is the passenger count. Trip is the direct copy of our Parquet file, and passenger count is basically the aggregated stuff which we did. And if you, the other thing which, if you remember, I mentioned like if we don't create a database, like there will be a default Spark database, and it, I know like here it looked like okay, it's stored in like it looked like a table and a database, a table kind of structure, but actually these two are stored in the data lake. So if we go yeah, look in the workspace. See, New York Taxi DB. So it's basically stored on the data lake, but it's for a user, it's presented as a database and a table, which is a good thing. So this is a personally, and then the last thing I want to show, like if this is a Spark table, but still you can do a SQL script on it, and you can literally do like a Spark stuff on it. And same goes with the uh, with like SQL databases too. Like with this, we can do a SQL script and a node like a Spark job too. Personally, I like that. Like we can change things. We can use SQL and Spark interchangeably, but it depends on your preference what you want to use. In today's video, we will look into the Azure SQL service. Okay, so Azure SQL is a unified SQL service built on top of industry-leading SQL Server engine. That's also known as Microsoft SQL Server, which you guys might have used in your day-to-day job. So Azure SQL have three deployment models, which we will see in the demo too. Here you can see that like the first one is the SQL Server on Azure virtual machine. Basically, it is an infrastructure as a service model, which is basically SQL Server running on Azure virtual machine, And in this case, Microsoft going to manage the host and the infrastructure, while we as a user will manage the operating system and the SQL Server application. It's best for the migration of those SQL Server applications which require OS level access. So it's like one of the best option for lift and shift scenarios where we have to migrate a SQL Server application which requires OS level access. There are Microsoft have two other services which they are served as platform as a service. One is Microsoft SQL managed instance. The other one is the Azure SQL database. So Azure SQL managed uh, is basically where like Microsoft is managing the infrastructure and OS. We are managing the server and the application. It is also best fit for those left and shift scenarios where we don't need the OS level access, and it is a good service which do the lift and shift with minimal to no database change. It's pretty much same as like a on-prem SQL Microsoft SQL Server. And the last one, which we uh, is Azure SQL database. So it's also another PaaS, or you can say platform as a service. It add one more layer to Microsoft management, that is the server. So Microsoft will be managing the infrastructure, OS, and servers in this case, and this is like best suited for any application which is like built on cloud, or any new SQL server you want to establish, like use Azure SQL database. Next thing, we want to look into the Azure SQL purchasing models. So basically there are like two models. One is DTU and the second one is the vCore. And DTU is only available on Azure SQL database, while vCore is available on SQL database and the managed instance. And DTU have we're going to see in the demo too, like what's a major difference, but basically you can see from the like names, like it's like basic, standard, and premium. So basic is like basically for like small jobs, or like for example this demo, they are like basic will work. Standard is more like a general purpose kind of thing, and premium is like for any applications which need more horsepower to run basically. And you will be wondering, what is DTU? DTU is like a predefined unit of Microsoft Azure, where like it's a combination of input output plus memory plus CPU. So here with DTU is like it's predefined for you. You can't change it. Either you can pick basic, standard, or premium. Like you will see the difference there, but you don't have a choice to uh, like a change in, like let's say you want to change memory in standard, you can't do that. So to overcome this problem, like they have another purchasing model, which is vCore. And vCore is it's of three types: general purpose, business critical, and hyperscale. And as the name says, business purpose is mainly for general workloads and queries, and it most of the cases like it serve the purpose for all the clients. But if still they have some business critical applications, then they should use the business critical purchasing model. And the last one is the hyperscalers. That's for I'll say like another level of applications where you can't be down for or you need this um, or like a more horsepower to run your queries, or to pull data and all those kind of things. And as I mentioned, it's available in both Azure SQL database and SQL managed instance. uh, the one good advantage where like vCore uh, comes into the picture, like it's with those clients which want flexibility in like picking up their resources for Azure SQL. So this give you, like we'll see like how you can pick different number of cores and different kind of options with vCore, but with DTU it's not the case. Oh, so let's do the quick demo. Okay, where is Microsoft? Is it? So I've already created like one resource, like I'll say a SQL, Azure SQL server and a database, but I'll start from here. Like if you press on create in Azure SQL service, you will see these three options which we talked about, like SQL database, SQL managed instance, and SQL virtual machine. And as we mentioned, like SQL database is mainly for cloud application, hyperscale, or serverless options. So basically there are like three types of resource types you can get in there. The first one is the single database, elastic pool, and database server. So single database is like when you are managing a single data set, or everything sorry, the single database is like when all the resources are dedicated, you're not sharing anything. But with the elastic pool, like you're sharing your uh, data sets with the, it's a pool where like all SQL instance share things. And the last one is the database server, which is basically you need whenever you want to create a SQL database, like you need a database server, and which is it's just a logical grouping here. Like it's not a physical server for us. So you can look at this like single database, as we mentioned, like it's for like a fully managed database service. It's not sharing anything. Elastic pool is like where multiple databases are sharing the resources, and this is basically you need a database server. That's a logical grouping of all the databases. It's pretty much like the we have on-prem, but like it's here it's managed by Azure. And managed instance have only one way of resource type, which is single instance. And the last one is the virtual machine. Like it give you multiple options where you can pick up the image you want, and whatever server and whatever OS you want, you can pick it up. Only infrastructure is maintained by Microsoft. Okay, if let's go to, yeah, first I'm not going to create it, but I will show you what actually comes in this SQL manage instance. So if you click on create, so here comes regular stuff like subscriptions, pick a resource group, and this is the thing I was talking about, the compute and storage. So you can go and click here, and here you can see they have general purpose, business critical. I know like a hyperscale is not visible here, but hyperscale is available in the SQL database. So this will give you like how many vCores you want and what's the storage you want. So it gives you the flexibility to pick it whatever you want, and you can see the based on your vCores or the storage, your price per your price change. So if you want like let's say 64 bits, it will be like 15,000. And that's why like if you want to practice or something, don't create a managed instance, because it might cost you a bit higher. So go for the basic in SQL database, Azure SQL database, not this one. So even the lowest is like $960 per month. So that's how I wanted to, and they have the redundancy, which is like a geo, John, and local. That's to give you availability and the disaster recovery options. This is the main thing I want to show you. Rest of stuffs are pretty straightforward. If I go back, okay, one second. This is the SQL instance, and here like you can pick an image and it will be straightforward too. Let me pick, there was like one free SQL, yeah. So you click on create, and then you give the like same thing, subscription, resource group you can pick, and then you give the machine name, reason, availability options, which one you want, and some other kind of things, like not very complex but like very intuitive. This is not very complex, very intuitive. And here also, like if you, this is also like a bit costly, so choose accordingly. When I say costly, like as a, if you this like, because you, if you're doing this for learning, so be cautious like how much you want to pay. Let's I'll show you this one, the single database. So if you click on create, so same thing, database. I already have one database, but I'll create another database. Data Tech DB2 and server. Like if you don't have a server, you have to create a server, but it's just logical, like it does not charge you, so don't worry about it. So you create the server, and this is the elastic pool. So you this options is basically whether you want to share your resources with or not. So you can switch it to yes if you want, otherwise no. And configuration database, if you go here, so here you will see all these: general purpose, hyperscale, and business critical. The other difference which I didn't mention, but it is like your, so when I say difference, so if we look at the Azure SQL database or Azure managed database, what's the difference? So the first difference is like the purchasing model. Like if we go back here and look at this, sorry, so you look at this. So Azure SQL database have one more like DTU purchasing model, but Azure managed don't have it, only have vCode, and even in vCode, like it doesn't have hyperscale. The other difference is like Azure SQL database have serverless option, which is like basically for those jobs where you don't know how much resources you're going to consume. So it's have two compute tiers. One is the provision, other is the serverless. So you can go for serverless. So these are two main difference, like the purchasing model, and you can have a serverless option in Azure SQL database. And these are general purpose, hyperspace, and business critical, which we talked about, like depending on like what kind of job you have, or depending on your requirement, you can pick accordingly. And these are the other three, like basic, standard, premium. And if you want to experiment with it, just take basic because it's cheap, like $6 or $7 per month, and you can click on apply. You can pick others too, like if you want to spend money, or like if you're not learning, or you're doing it for your organization. Okay, I'm not going to create it because I already created, so I'll go back here. This is my server, and this is my database. So in this database, I'm using the same basic 5 DTUs. So if you go here, so to access this database, there are like two ways to do it. One is through query editor, which is in the preview. Like if you want to do through the GUI or from the portal, you can go from here. Like for example, this is my login, and I can log in. Okay, and you will see like it's pretty much like I don't have any tables or anything. Like this is not we're not going to do it, we're not going to create any table or something like that, because that's, we all know, like we all understand SQL and all those. This is more about like what is the services, and same thing you can access through SQL Management Studio. So for that, what you need, you basically go here, copy your click on this, like copy your server name and go to SQL. I already connected, but like we can show you. So this is the same authentication. You have to take SQL Server authentication, not the Windows authentication, then your admin and your password. So we are connected here. This is our database name, and this is like literally like a Microsoft SQL Server, but it's running on Azure. So this pretty much, but I want to mention one more thing here, like which you need to keep in your mind. When we create the Azure database for first time, it have firewalls, so you need to set the server firewalls for it. So what would that mean? Like for example, if you like you created your server database and then you want to log in into it, if you, even with the, like it will throw you an error that this ID is not allowed, like IP address, sorry, not ID. This IP address is not allowed. So by default, no IP address is allowed. So to add the IP address of your system, like whatever, like let's say you try to log in and it will give you an IP address. So copy that IP address, go to overview and set firewall. And then here, like you can see, like you can make rule, start IP, end IP, and you can add it. And here you can see this. This is my IP address, which I added. Okay. So that's pretty much for Azure SQL. In today's video, we will cover the partition strategies, design, and on various app services, mainly Azure Data Lake Gen 2, Synapse Analytics, and Cosmos DB. And even we are going to cover the distribution strategy in Azure Synapse Analytics. I'm not going to talk about what is partitioning, what are the advantages, how it benefits, because that's we all aware. So without further ado, let's jump to the partitioning in Azure Cosmos DB. So as we saw in Azure Cosmos DB video, while creating a container in Cosmos DB, we need to define a partition key. And partition key is the value by which Azure organizes our data into logical divisions, or you can say the items in the containers are divided into distinct subsets. That's called logical partitions. And you can see in the image too, like database have two containers, and the first container partition key is city, and after that these London, New York, Paris, this is the logical partitioning. And same thing for the second container partition key is airport, and these are the logical partitioning. So this stuff is the logical partitioning, and once the data is logically partitioned, Cosmos DB engine decide where these logical partitions will be mapped to the physical partition. Or basically, like you can think it's like internally one or more logical partitions are mapped to a single physical partition. So here you can see London, New York, Paris, they are partitioned here. Same Rome is partitioned to this. So this is done by Azure Cosmos DB engine. We have no control over it. So next thing is avoid hot partitions. So basically we don't want to be in a situation where one of our logical partition is overflowed with anything. So like basically there are two things which a partition can be overflowed. The one is like the way we are storing the document into the container, into the logical partition of the container. So as you can see here, like in this on the right hand side, like this partition have more document than others, and this is unevenly distributed. So this is called hot partition, and because it's like overflowed with the documents, and we don't want to go into a hot partition situation. And similarly, we have to avoid the hot partitions on the throughput too. So that means like our query which is hitting these specific that means like our query is hitting only one partition specifically more than others. So we don't want to go into that situation too. So always we have to make sure that we don't create hot partitions either from storage or throughput perspective. And there are some best practices for partition keys while designing. So the first thing which we need to keep in mind, like the partition key has to keep the data evenly distributed. As we saw, if it's not evenly distributed, we will create that will result into the hot partition. So and and the second thing is like it need to have high cardinalities. If you have a lot of values, like a lot of varying values, it's really good. And in such situations, like you won't be able to find a partition key directly from a field in the document. Then in that case, you can create a composite key. That means which is like basically combining two keys, for example date and the ID. And second thing is like write the queries which are evenly distributed too. So like write the queries in a way like they are not hitting only one partition, and has to be static values, like they don't change that much. So for example, a partition key so for example, date could be a bad partition key, because in this case, like, it's changing every day. And the other problem with it is, like, let's say if somebody is querying the data from one specific day, like you just hitting one partition and creating hot partitions. So that's like depending on your use case, date could be a good partition key too. So keep these things in your mind while designing, but also you need to keep in mind that document and partition like limit, like we need to keep in mind the like the document size and the partition size in mind while designing the partition key. So maximum document size is 2 MB. If it's more than that, we have to like, we can't do it. And the same thing with the logical partitioning, it could be 20 gigs only. So now look at the implementation of Azure Cosmos DB partition thing. So as I've already created a Azure Cosmos DB account. So we go there. If you remember from our last videos, we go into overview, click on add container, and here, like, we give the name to the database. Let's say it is OLTP. Then change the container, like that's the container is families. Okay, let's make the container as org, and the partition key will be the ID. So like I'm picking ID, but you can pick whatever it is in your document. So this is the place where you implement your partition key basically. And we need to, whenever we implementing the partition key, we need to keep like partition key best practices in our mind. One of them is basically like you evenly distribution, static. If it doesn't exist, use a composite key, and avoid hot partition and those kind of things. Now let's jump into the partitioning in Azure Synapse Analytics. So Azure Synapse dedicated SQL pool distribution and partitioning. So in Azure Synapse Analytics, which was formerly known as Azure Data Warehouse, Azure Synapse Analytics automatically shred or do horizontal partitioning of data into 60 distribution to optimize the performance of the system. So as you can see in this image, like a table will be divided into 60 partitions over the compute nodes, and compute nodes you picked while creating your dedicated SQL pool. So basically, whenever you're creating a table, it's automatically already distributed or sharded, you can say, or horizontal partitioned into 60 times. And we as a user only can pick sharding or distribution pattern when we define the tables. So mainly like hash, round robin, or replicated. If we don't mention or if we don't like when we defining the table, we don't mention about the distribution pattern, like round robin will be the by default choice. So there are basically 3: hash, round robin, replicated. If we don't define, round robin will be the by default choice. Now look at them in more detail. So basically the first one is the replicated, which is what it do, it like replicate your table 60 times on your compute nodes. So this is ideal. So what that means is, like, your table will be, like, all the records of your table will be distributed 60 times on compute node basically. And this is ideal for like small dimension tables in star schema, which are less than like 2 gigs. And this is like 2 gigs after the compression. So Azure by default do a compression of I guess 5 times from the actual size. So basically it's good for small dimension files, or like dimension files or lookup files which are less than 2 gigs. And don't use replicated as a distribution when our data warehouse units are changing, or like our table have a lot of like write up transactions. Like it's keep updating basically. So it's good for like dimension tables and lookup tables. Don't use it when we have to do multiple write application transactions on the table, or we keep changing our data warehouse units, which we pick when we creating the Azure SQL pool. Round robin, which I mentioned, it's a by default. It is idle for staging tables, and it's idle like when we can't find a joining key, or we can't. And this is also like idle, like let's say if we can't find a single key to distribute, which is like a requirement from hash, we won't be. Then in that case, use the round robin. But the problem with round robin, because like it has to shuffle a lot of the data, so performance could be slow. So if your data is like need a lot of complex queries or something, don't use it, or like if they're large in size. Hash is the last distribution, which is basically ideal for the large fact tables, or like historical, like basically large size tables are the good candidates for it. But if table don't have columns which can be used as distribution, please don't use it. And distribution key should not be cannot be updated. So if you pick a key which keep updating, like don't use it as a distribution key. And any column which is like nullable is not a good good option for distribution. And the similar with the like a column that has a default value is not also a good option, because then it will like put a lot of records in those nullable and the hash ones. Nullable and the with the default values. So basically, like the best practice is pretty similar to the partitioning in Azure Cosmos DB. Is like the first thing is it need to be evenly distributed, like it distribute the data evenly. Second, it's like static, like it does not change that often. And the last thing which is different is like we need it, any hash key will be any hash key which have more than 60 values will be a good hash key. So implementation is very straightforward. As I mentioned, we can define the distribution at the time of our DDL, or like when we defining the table. So here you can see that like we just creating a table, name, fact, internet sales. These are the columns, type, not null, and in the end just you need to add width. This is our compression, so we're going to talk about that later, don't worry about it. But like distribution is basically distribution equal to hash product key. So in case of replicated, you just need to do distribution equal to replicated. In case of round robin, you don't have to do anything, it will be by default. So it's very straightforward, and this is the implementation. We're not going to demo it because we can't see those 60 distributions, but this is like that's like behind the scene kind of things which we can't see it. So but for understanding like how it works and how we can do it. Now you will be wondering, like, if Azure dedicated SQL pool do the distribution automatically, or like you can say shredding automatically, do we need partitioning or not, or is like that's done deal. So so answer to that is like in some cases you might still need to do the partition by your own too. So basically whenever we doing partition in Azure Synapse dedicated SQL pool, we need to keep the factor of 60 before doing the partition. When I say factor of 60, that means like those 60 distributions, because we don't want to kill the performance of Azure Synapse Analytics by over partitioning. Because like if we have like thousands of partitions, it will slow down the Azure Synapse Analytics. Like whenever you're querying, like it have to go to so many partitions, like query result, like the output will be very slow. So recommended is like 1 million rows per partition, not exactly, but like close to that. So just think about it, like if you do 100 partitions by yourself, and I'll show you how you can do that. That's easy too. We can do at the when we defining the table. So let's say we did like 100 partitions on the table. 60 partitions are already like it's going to be done by Azure, like whether we do the partition or not, like Azure is going to do that 60 partitions. So we creating in total 6,000 partitions, and as the recommended storage per partition is 1 million rows. So just imagine, like we need 60 billion rows to get the best performance. So if we have the data which have like 6 billion records, we will go for it. If we don't, like if it's like very less number of rows or something, we'll stick to the distribution. So we have to make a decision while like after knowing our data, we have to make a decision whether we want to do partition by our own, or like we should be okay with the distribution. And as you can see, it's also pretty straightforward. Like it's here, you just start with the partition keyword, and then whatever is your partition key and what's its range. So it's straightforward. And as I mentioned, like we can't see the partitioning, so we just need to know how we need to do. And as I mentioned, like a SQL pool automatically do the distribution, so we need to keep that thing in mind before implementing our partition, because we don't want to jeopardize our Azure Synapse Analytics performance. Oh, next and the last is the Azure Data Lake Gen 2 partitioning. And if you remember from our last video, but like from the Designing Azure Data Lake Gen 2 video, like we talked about the folder structure has to be like subject area, date, year, month, and DD. And even we saw there, like we manually created the structure, but that's not how things work in a real world. Like you can't manually create structures like our code, because anything storing into Azure Data Lake Gen 2 has to create the structures. So in this case, like let's one second. Yeah, in this case, we will see how from Azure Synapse Analytics or Databricks, you can imagine, or any like place which feeding the data from like Spark can create the structure. So let's sorry, one second. What's the next slide? Yeah, let's go to the implementation of it. Okay, that's here. So basically what's happening here, this is my Azure Synapse Studio, where I'm reading this data sets. I've already ran this code, but I'll explain what exactly here is what we are doing. So this is we just telling like this is our magic PySpark language query, and here we are importing some functions which are straightforward: year, month, day of month. And after that I'm reading our green taxi trip data. I have manually uploaded that, so let's go to here. So I've created like two raw and clean folders I've created manually, but after that in raw I uploaded this CSV file that is the green taxi trip data, which is like open data sets from New York available. And after that in clean I didn't do anything like this. Everything is done by our code. So basically what we're doing here, like if you look in the first line, we are importing year and month. Then after that we're reading this data. So you can do this. Yeah, so we're reading this CSV files from this location into this data frame, displaying 10 records which are presented here too. And after that we like simply creating new column, year, month, date, and there was like a field available, like you can see it, like I picked this field randomly. I don't know what exactly it is, but I picked it to just show like, okay, how we can create how we can create a folder structure like this automatically instead of doing manually. So let's go here. So I just created 3 new columns: year, month, date, and then I fetches the year from here, month, date, and then I simply write it back by partition with the override mode into into the clean folder. So this is my location, this is my mode, and these are the fields by which I did the partition, and this is what we wanted you look at here, this is what we want: year, month, date. And if we go and look into our Azure, so you can see year, then you can go month and day. I know like this looked like 1 day of data because I just took a sample, but the idea is like that program is creating. And here you can see we have 2 months, and you go in here, oh, see, boom, this is like multiple folders or multiple days, and you go there, this is our Parquet file. So this is how you do the partitioning in Azure Data Lake Gen 2. And if you stay here, this is the Azure Data Lake Gen 2 I'm using for, which is mapped along with Azure Synapse Analytics. So that's all for this video. In today's video, we will be covering archiving in Azure. So without further ado, let's start. And we will be covering designing an archive solution, and we will do the implementation too. So here's the introduction, and this is just basic knowledge: what is archive and why we need it, or you can say what are the use cases for it. Archive is basically moving the data into a storage or in a place where we don't have to access it very frequently, and the data is still important. The use case, the classic use case is the regulatory standards or compliance. Most business use data archive for legacy data or data that required to keep in order to meet the regulatory requirements. Archive in like a different data storage of Azure. So Azure Data Lake Gen, here we're going to see how we can manage the life cycle of the data in storage account, or you can say the retention policy, or how we can do archive the data. In life cycle, like data goes from various access tiers and before it get deletes. Azure SQL, like here the archiving is done by exporting and storing the data into Azure Data Lake Gen 2. It's simply, and once the data is stored in the Azure Data Lake Gen 2, the same approach will be used for the Azure SQL 2. And Azure Synapse Analytics and Cosmos DB don't have any built-in or like out-of-the-box capabilities for archiving, but they have like other options, which like in Cosmos DB we can use TTL, that is like time to live, for retention, which is defining how long we want to keep the data, and data will be deleted automatically after that. But still it don't have like a life cycle management kind of thing, which we have in Azure Data Lake Gen 2, like where you can go from different access tier or like different storage type, you can say, from hot to cold, and then archive and then delete. In Cosmos DB, like after a certain time you have to delete it, like that's a capability available. And similarly for the Azure Synapse Analytics, like we can delete data using like by writing a custom store proc or the delete commands that okay, delete any data after let's say certain inserted dates or certain time. But that's like one way of retentioning the data, or like you can say implementing the retention policy, or even archiving the data. But here too, like we don't have a life cycle kind of capability where like you can go through the different access tiers. Now next is the implementation on Azure Archive, like implementation of archive in Azure Data Lake Gen 2. Let's go to the, yeah, perfect. So you basically need an Azure like a storage account, and there you need one container, and you can upload a file to that. Okay, let me go there. I already created the storage account. I have a container too with the name raw, and I have a file in it. Before we look into the lifecycle management, or like we look how we can do things at a like a blob, like at a storage account level or at a container level, you can like literally move. One second, sorry. Yeah, like if you select a blob, you can change its tier from here to directly from hot to cold and archive. But this is like more manual, and it's not like it's not sustainable. Like it's for one-off kind of situations, but that's not our idea. That's like just I was doing it just to give you an idea. Like you can go to a single storage or individual blob or a single blob, and you can change the access tier there too. Now let's go to here, scroll down, like click on your storage account, and you can search for lifecycle management, or you can scroll down, and in data management you will be able to find this. One second, where it goes. Yeah, lifecycle management. So here you see I've already created a rule, but like for demo we're going to create a new rule. We'll click it, we give it a name to it. Let's say 42 is the name, and then you have to pick the scope of the rule, like how you want to apply it. Like you want to apply it to the all blobs in the storage or on the limited blobs. When you say limited blob, like we will have to set the filters, and we will look into that, like how we can do that. So let's start with like limited blob, and then the blob type, like whether it's a blob or append blob, and blob subtype like a base, snapshot or version. Let's select version 2. Depending on your requirement, you can pick blob type and blob subtypes. And blob subtype, blob type append might not be like eligible for all the actions, but like we can, like if you want, you can look into the documentation, but I'm pretty sure like it's not eligible for all the actions, and we will see like what I mean by actions here next. So this is like you add a rule. So this rule says like if base blob is last modified, like we give a number. So based on your requirement, or like the way you want things, you or based on your business retention policies, you can pick these days. So let's say we are saying after 30 days move, we don't want to delete this, like we want to move it from hot to, let's say, cold storage. Then we can add another rule which says, okay, after 180 days move it to archive. Yeah, move it to archive. Then add another which is like after, I'll say let's say 1000 days, like almost 3 years, just delete it. Okay, this is for base blob, and we have to do the similar thing for the versions blob 2. And here like versions, basically like you directly delete them. So let's say delete the versions after 90 days. Click next. Oh, sorry. And then you can add the filters. So basically there's like 3 types of filters. One where like you specify the blob which you want, and the other one is the blob prefix, where like you give the location name. So let's when I say let's say when like location means the container name where you want to delete all the, so I can say raw, yeah, that's my folder, and click add. So you can see now our new rule is added. And when you select the rule, like this is like you doing it through the interface, but there is a code view for it too. Like if you click on this, you will see the code view. Okay, and this, now I'm going to explain what exactly in the code, which is like pretty same what we did, but I'm going to explain it to you. But the other thing you have to keep in mind, like this life cycle runs once a day. Okay, now let's look into the code. Let's jump to the code. So to make your things simple, like I have like once again, like if you go, this is a JSON, and I'm going to explain all these things one by one in there. Okay, so here you can see one rule is this for us, and this is the 42. This is the another rule. So there are 2 rules in there. That's why you like it, this look a bit longer. But let's look into this. I have break it down to I'll say step by step to understand it in a better way. So the first JSON script is like, or you can say the first object is a rule, which is an array of rules objects. So you can see it like it's an array from here to here, and it can have, as we define multiple rules, you will create an object of it. So this is going to be one rule, this is going to be another rule. Now after that, in the second, the rule objects have like 4 keys here, like name, enable, type, and definition. And the definition and these have the, like, name will have the name of the rule, then enable will always be true, what type of it is, like lifecycle or something. And then in definition you will have another JSON objects which will have key values thing in it. So here you can see this is one rule, this is another rule, and this is an array. From here to here, you can, from these brackets, you can identify this is an array of rules. One rule, another rule. And now and in the third script, you can see the definition object have action and filter objects within it. And also notice now we have only one element of array, sorry, one element in the rules array. We don't have like 2. I removed the other one, so it's like just one rule from here to here. And in that rule, name is there, enable, type, definition. In definition there are 2 other object, actions and filters. Now if we go to another level, or the next level, in actions you will see there are 2 other objects which are the types, or you can say subtypes of our blob. So version and base blob, which, like, when we were like doing it manually, like if I go back here, sorry, when I say manually, I mean like on the interface, these are the things. So if you select snapshot and version, in this code you will find a version object, a base blob object, and a snapshot object. For example, I just took 2, but you get the point. Like whatever subtype you pick, you have to enter here. And then after that, in the 5th script, you can see for each blob type, like blob subtype, basically like version and a base blob, we have actions and action run condition basically. So they're like some predefined actions. One is delete, tier to cool, tier to cool, tier to archive, and there's like a couple of more, but you can check the documentation for that. But the idea is like each sub blob will have its own rule, its own action, and the action run condition. So here you can see here for the version, which was like we did in our interface 2, like if it's a version, just delete it after 90 days of creation. And for the base, it was like a 30, 90, and I put it like 2500. Like first go, like after 30 days it will go to cool, then it will, like after 90 days it go to archive, and then after 2500 days it will be deleted. And last is the filter function, which we saw in our GUI 2. Like you have to enter, like you can use prefix match, or there is a blob type too, where like you literally enter the name of the blob, and prefixes basically you tell like, okay, this is the folder, and anything in that folder will be like all the lifecycle management will be applied there. And you can see these are both are arrays, so you can add like multiple. For example, in prefix, like you can have more path in there. Okay, let's go back here. Sorry, yeah. And now implementation in Azure SQL. So that's let's go back again to our portal. Okay, home. If I go to Azure SQL, so Azure SQL is going to be very simple, not very complicated. Like as I mentioned earlier, like they don't have like Azure SQL also don't have a built-in capability. So what we need to do, we need to export export and store those like we need to export it as a backpack file and store it in the Azure Data Lake Gen 2, and there you can like use the same like lifecycle management which we saw just now. Okay, go here. So you see here, like you have to go to your SQL database, and there is an export button. So you click on that, then you you give it the name of your file, Azure, like you pick your subscription, and then you select the storage, and you can go directly to wherever, like for example, we can go select raw, and the rule we created, it is already applicable in raw. So this, like, it going to be applicable on this file too, and this file type is backpack. And after that, like, you just need to provide your server name and password and click OK, and it will be exported there. It will take time depending on the size of your database. So recommended is like do this activity weekly, I'll say, or depending like how big is your database. I'm not going to do it because I don't have anything in there, but it will be stored in the like in a container, and you can add the same lifecycle management on the container, and your file will be, then it will have the same you can say same archiving strategy as for the Azure Data Lake Gen 2. That's all for this video. In today's video, we'll start looking into the design and develop of data processing. The topics we will cover here are transform data by using Apache Spark, cleansing data, performing data exploratory analysis, cleaning and transform data using T-SQL. So for Spark, let's jump into the demo directly, or look into the code directly. Perfect. Here we can use Azure Synapse Analytics. Here we are using Azure Synapse Analytics, but same things can be done in Azure Databricks or HT Insights. For Azure Databricks, like, you need to mount the data lake where the data is stored. Like in this case, we are using the open data set, so you need to mount the data lake wherever you store your open data sets. Let's look into the code and try to understand what kind of transformation, cleaning, and exploratory analysis we are doing. So if you look into the first cell, we are reading New York taxi data from open data sets in Azure ML library or package. And we are also importing date time and date util libraries, and from there, like, specifically date time and the parser functions. And this is just to get the dates in our code. And here we are setting its two variables, which are end date and start date, and after that we are using these two variables to fetch the New York taxi data. So we are reading, or you can say extracting, only 12 dates of data from June 2018 into a data frame. Once the data is loaded into the data frame, the first step in real world too, or generally, is to understand the data. How we understand the data? We need to perform some exploratory analysis. So it's always a good practice to perform exploratory analysis on each data sets which you read. So the first thing we check whenever, or I do that, like I check the schema of the data sets to understand the what's the structure of the data. So when I say structure, like what are the data types and etc., data type and data size and all those kind of things, I look into this. So if you look at this, I have already ran this code, so we can look into the output. So here you can see this is the schema of our New York taxi data, where we have vendor ID, which is an integer, whether it could be nullable or not. So these kind of things help you to understand, like, okay, what is the data type of the columns which I'm going to use, and how if you want to modify it, or let's say if you want to join it to something, we need to keep data types in our mind. Otherwise, like when you're joining, let's say, vendor ID in this data frame to something where like vendor ID is stored as text, you won't be able to join it. So those kind of things give you an idea, okay, what columns are there, what data types are there, whether it's nullable or not. And after that, we should check the data with limited number of records. So when like you show, displaying only 5, but like a general rule of thumb, like do at least 100 or 500. So in that way, like you actually see the data here. It doesn't look because of the number of columns, it doesn't look really good, but this give you an idea, okay, how my data set look, and like the fields you want to use, like what type of fields and all those kind of information. This is like a stepping stone for further exploration. And the next thing is to always do the count on number of records. So you just want to be sure like um, like how many records you are extracting. And the other thing is like you also want to make sure the number of records you are extracting from your should match to your source. So this is also another good practice. And for exploratory analysis, you can do like a statistical measure, I'll say like a measure on measure, like statistical check on measure properties. And this will give you, if I explore this, like this will give you the value of like what's the, how many counts, what's the mean, standard deviation, mean, max. And this helps a lot like if you're doing advanced analytics or these kind of things. Like it helps in data science and uh, uh, advanced analytics project. May not be in reporting projects, but like in analytics and data science projects. And after that, like I'm just like cleaning the data here. And the cleaning the data is basically based on your business and technical requirements. So it could be like just removing some columns which you don't need for your reporting or like analytics or any further down the line, filtering the data. So where like you removing something which you don't want, how you want to treat your null values, those kind of things, how you want to treat your dates, like because dates is always like a one thing which when you move data from one source to another system, it sometimes changes, or like you need to keep date um, in your mind. So like in some places you will see it's a date timestamp, in some places it's exactly date, and some places like when they read, like for example in Hive they convert it into string. So keep like you need to be aware about these things, and you need to make your um, transformations, or I can say data cleaning by those things. And in this example, like we are just simply removing some columns which we don't need, and after that we just like filtering some like we are filtering, removing those records, uh, which removing those records which is null for pickup longitude. This is like an example, but it can be different in your use case. But this is just to give you an idea like how what is cleaning and exploratory analysis of data means. And after that, like I'm performing like some transformations, and again transformations depend on your requirements. But in this example we are creating various columns. You can see it like this is our database, and we are creating like date, time, month num, date of month, date of week, and hour of the day. These are the like columns which we created. I mean, we fetched all these information from pickup date time. And in the last column we just like added an extra column named country code and filled with the literal value US. And after all these transformations, like the next step we are doing is we are just enriching the data with the Holly data that's also available in the open data sets of Azure. And with this data also we will do some basic cleaning and transformation, and then join it to the taxi data. And you can see here like we're reading from the same package, and after that with using the same start and end date, and storing it in a like a data frame, and just seeing like top five records of it. And here, as I mentioned, like we'll do some cleaning and some transformation. So you can see like we renamed uh, country code to country region code, and we fetches that, like we created a new column named date time, and this we got from the date field. And after all, like after that, we are seeing what, like how our data look now. And next is like we doing the join to the New York taxi data. You can see it's a left join, and this is a join on these two things. And after that, like it's a join on these. After that, we just simply displaying the data, and then we creating like a temporary table, and just doing some Spark uh, query on that, like, and which is basically a straight query. If you look at, like, we are selecting all the records and where holiday name is not null. uh like further, we like in this notebook, I'm going to post this notebook in the in my GitHub repo, and the link will be in the description. So you can see like it's like just using another data sets, and like doing this similar kind of things, like um, joining it with the, like, our old data sets, doing some aggregations, those kind of things. You will see it here, so you will understand it. Like it's nothing very complicated. Like here you can see we are filtering stuff and all. So this notebook will give you like a good idea of a Spark transformation, how we do transformations, or how we do exploratory analysis or um, cleaning of data in Spark. Now just let's jump into our SQL. So for SQL, we are not going to have any code or something. We just going to have a discussion, because we all use SQL in our day-to-day life, and we are aware about all these things. So, but I just wanna mention so we know what exactly is cleaning and transformation um, we do in our day-to-day SQL life. So even in SQL, like we all aware that the real world data is messy. It's the same goes with the SQL too. And when I say messy, it doesn't mean like a in relational databases, like it's in a raw format, but it's most of the time it's not in the right format which you want to consume directly into your SQL for reporting or analytics and those kind of things. So we need to transform as per our needs. And here we're going to talk about some general use cases where we need to clean and transform things in SQL too. So the first thing is the null values. We see it like a lot in, like, a lot of the columns have null values, so we use aliases there to clean those kind of null values, or even sometimes like we filter out those records where the value is null. Second is the calculated fields. Like we have to create some calculated fields using the case when. So I'll give you an example. So let's say um, you have a like a country as a country as a column, but you want to create a new field name continent. So there you can use case when. So for example, case when country is Canada, so continent will be North America. Case when country is India, then continent will be Asia. So those kind of things. And third is the data type. So basically with the data type is we have to cast data types a lot of times to based on our requirements. So there we change data types using cast function. In some cases like it's explicit too, but in some cases we have to do it. The fourth thing is the dates. As I mentioned with the Spark, that dates are the something which is, in my experience, like it's more messy than other data sets in a lot of times, because dates are like sometimes it's a system dates, depending on from what source it's coming, what another thing like a what time zone we are using. So those kind of things we need to keep in mind. And there are like so many functions available in date, like already existing functions which you can use to extract the right dates. And We saw it in the Spark column, in the Spark example too, where we extracted the different parts of the data from one field. Um, Duplication is also another thing which is part of the cleaning. Like we don't want to report on like duplicate numbers, so we want to make sure like our data is distinct and we're reporting the actual facts, not the skewed facts. And the last is the string. So for string we have so many functions. So strings like sometimes we just need like only a portion of the string. And so one example could be, let's say you have a message or comment field which can have any, which is like a free text and allow users to input anything, but we are looking for only those records where user mention about let's say they use like a foul language, or they talking about a specific product of our company. So they're like, we have to use either regular expressions or like built-in functions or like kind of um, operation like kind of operators, where like you put a condition in where clause where like, and put a percentage whatever you're looking. So these things are basically like a cleaning and transformation of data in SQL, and it's pretty like general in every SQL. So same things apply for the T-SQL too, and you can go deeper and deeper. Like string have its own list of functions. Same goes with the dates, but this is just to give you a general idea like how cleaning and transformation do. And the idea here is not to give you an example because we work with SQL a lot. Safe. In today's video, we will look into the batch processing using various Azure services. And this video will definitely going to help you to understand how multiple services of Azure can be used to create a batch data pipeline. The topics which we'll cover in this video is developing the batch processing solution using Azure Data Factory, Data Lake, that is Azure Data Lake Gen 2, Spark, Azure Synapse pipelines, Polybase, Azure Databricks, and obviously we will going to create a data pipeline using all these services. In this pipeline, we will be using a dummy data of a bank, which will be in JSON format, and that will be stored in the Azure Data Lake Gen 2, which you can see in this architecture too. There are going to be 3 JSON files which we're going to store in Azure Data Lake Gen 2. That's going to be our storage. As we can see, also there is going to be 2 pipelines. So one is this, the first pipeline is using the Databricks, and the second pipeline is using the Azure Synapse Analytics pipeline, or we can say Azure Databricks. Finally, from both pipelines, we're going to store the data into the Azure Synapse Analytics dedicated SQL pool. So basically, in simple words, we can say that our source is in Azure Data Lake Gen 2 and sink is the dedicated SQL pool, and data will be transformed by using Databricks and Azure Data Factory. And we also going to use the secret management services, which is Azure Key Vault, to store our credentials. And that's the that's the industry best practice to store like our credentials in a wallet, in a vault, or a secret management application, because we don't want to like expose our credentials via code to like to hackers or other people. So basically, like who don't understand secrets, this is basically we are storing our username, passwords, or like service ID, service account username and passwords. So we don't have to type them in the code. We can use this Azure Key Vault to get those values directly into the code. So you don't have to hard code your credentials into code, and you don't want to like risk or open your network to anybody else, like open your code or share your credentials with anybody else. So you can you can see that like there is going to be like it's a very simplified view of this batch pipeline, but there are going to be a lot of activities and a lot of steps will be involved. That's why I created a markdown which goes step by step, and the link of the markdown I've uploaded into GitHub, and the link of it will be shared in the description of this video. So let's next is the demo. So let's jump into the demo, and I'll give you I'll keep open my markdown too, so we are not missing any step. So this is the markdown which I was talking about. So the first step is to create Azure Synapse workspace with a dedicated SQL pool. I named it EDW, but you can name whatever you want. So I've already created a Azure Synapse Analytics workspace with the name of DataTech WS. And if I go to the Synapse Studio, I already have the dedicated SQL pool too with the name of EDW, but let me show you how to. If I go here, data, I just want to show you that I already have it. Okay, so how to create it? It's very simple. Sorry, my bad. Just click on create, and you pick your resource group, which is like logical grouping. So you can create a new one or you can use an existing one. Let's, for example, we take a data engineering, then we'll give a workspace name, whatever workspace name you can give. I'm giving S2. And then the storage, if you already have a Data Lake Gen 2 storage account, you can use that, or otherwise you can create a new one too. And similarly, the file system underneath, if you have already, you can use it. If you don't, you can create it. So it's very simple. If you go, and after that, you just need to, after filling all these information, the next step is like the security. So here you need to provide your username and the password, which we will need in Azure Databricks to connect our Azure Databricks to the Azure Synapse dedicated SQL pool. So you can give the admin name and username and password what you want. This is how you're going to create your Synapse workspace. That's the step one here, like creating Azure Synapse workspace. Once you fill all this information, you click on review and create. I'm not going to do it because I already have it, but that's how you create it. And once your workspace is already deployed, you click on it, open your Synapse Studio. So from here you can create the dedicated SQL pool, and there is another option. You can create a dedicated SQL pool from your portal itself too. So if you click on this, and you just provide the name and what's the hardware requirement for it. So if you go high, these are the higher hardware requirement, but if you keep it low, it's low. So in my case, I give it EDW, but you can have whatever you want. So it says because I'm using the existing workspace, it says it's already existing. I'm not going creating, but it's that's how you create a dedicated SQL. You just name it, pick your performance level, and then click on review and create. That's how. So that's, once you're done, you should if you go to your Synapse Studio, you should be able to see your EDW, and I'll show you how you can create a dedicated SQL pool in Synapse Studio. So open Synapse Studio, click on manage and new, and that's how both the portal and the Synapse Studio looks pretty same. And if you need more details, I have videos on dedicated videos on Azure Synapse Analytics. Okay, so the next step will be once our Azure Synapse workspace is ready, our dedicated SQL pool is ready, the next step is to load the data into Azure Data Lake Gen 2. So that is here. If I expand this is this is the place where we're going to upload. This is the file system where we're going to upload the data. I already uploaded the data, but as um, as this is not like a single file, as I mentioned initially. This is going to be three types of data, and these are dummy data for a bank system. So let's take a have a look into let's have a quick look how's our data, and then once you see our data, you will understand like what I mean. Like it's okay. So I'm exploring these data sets in Microsoft Azure Storage Explorer. So there are like three types of data: branch, customer, and relation managers. If you expand branch, there is a JSON file. Similarly, if I open relation manager, there is a JSON file. But if you open customer, you're going to see a year. If you expand this, then you will see month, and if you expand month, there's going to be a individual file for each month, each day, sorry. So you will see like on for day 1, day 2, day 3, like it's January, so you will see 31 files are there. So this is basically in real world you will see pretty much similar data, or pretty like data is stored pretty much in the similar fashion. So you can store, really you can observe like the customer data is kind of partitioned on year, month, and then there is a separate file for each day. So if you want to upload like I have this data on my local. If I go to download, like I already, so this is like a whole folder which I uploaded there. So if you want to upload that from here, there is no option on the Azure Snap Studio or even the portal. There is no way you can upload the whole folder layer. You can upload things like this upload as for individual files, not for the folders. So that's why we need Microsoft Azure Storage Explorer, which is very easy to use. Like its copies, like its exe file is available on Azure. You can download it and upload it. It's very as I said, it's very simple to use. Like once you download it, you just need to sync, or like you need to log in with your credentials, and after that you will be able, like your portal, so your Azure Data Lake Gen 2 is, or your storage account is synced with your Azure Storage Explorer. So here in user, you can see I've already uploaded like a data folder. But how you do this, you click on data, click on upload folder. Once you click on upload folder, let's say for example, if I go downloads, select this, and if I click on upload, it will upload. I already uploaded, but that's how you upload the whole folder. So we are not going to use the portal or Azure Snap Studio. We will upload using Azure Storage Explorer. Otherwise, like you have to upload it individually. And as you saw in our case, like for branch and relationship relation managers, it can work, but like customer data, which have like a lot of files in it, it's not possible, it's not feasible. After the data upload is done, we will create a blob storage and a container in it, which will be used as a temporary directory while we are accessing Azure Synapse dedicated pool by Databricks, and also it can be used for staging. Okay, let me jump into the storage account one more time. If I go here, click on storage account, you can see I already have blob storage named DataTech blob, but I'll show you how to create it. Click on create and just give it like a second, it will come up. So we'll create a, so it's also very simple. You pick your resource group. If you don't, you create a new one, then you give the name to it, like DataTech blob 2. Oh, that's already taken. Blob A. I'm just making up, and then like keep other things simple, or if you redundancy, you can keep it to local. And after that, like you don't have to make any changes. You just click on review and create. It will create a blob storage for you. It won't be a like a hierarchical namespacing, because we are not enabling it. So it will be just purely a blob storage. So that's how you create. And as I mentioned, it will be, we're going to use it as a temporary directory to access our like Synapse dedicated pool via Databricks, and also we're going to use it as a staging area for while copying. Like we can or we can't, like it depending on like you want a staging area, but that's why we're creating it. And as I mentioned, we need to create a container it. So I already have a container. If you go to here, click on block container. So I already have like a stage for SQL warehouse. This is like a name I gave it. You can give like stage or whatever you want. So now so far let's just have a quick review. What we have Azure Synapse Analytics. We have our like data is loaded into Azure Data Lake using these Azure Storage Explorer, and we have Azure Blob Storage. And the next is we will create a Azure Key Vault, and that's where like this is our secret management tool or service where we're going to add our secrets. And please keep in mind, like, okay, let me show you this. I already have it, but let's create a new one. So if you click on create, let's do it. Won't take that long. Yeah, so I'll create a new one. So let's give it Data Tech Key Vault 10. Okay, I'm in the East US, so you can pick whatever reason where you are located. This is something I want to talk about. So just keep in mind, if you want to delete your Azure Key Vault, like Key Vault workspace or the service, once after it is used, it's a soft delete. What that means, like you won't be able to use the same name for until next like 90 days. Like the data, like it will retain it. Like it's pretty much like an archiving where like data is archived in a place. It's not completely purged or it's not physically removed. So it's a soft delete. So if you want like you want to, like for example, if I created this Azure data tech key vault 10, and once I'm done using it, I'm deleting it, I won't be use the same name until like next 90 days. You can reduce it, like it's not necessary always 90 days. It's minimum, like you can read to 7 days. So I won't be able to use the same name for the next 7 days. So you need to keep that thing in your mind, because sometimes like even I got confused, like why I'm not able to use the name. So that's the reason, because it's a soft delete enable. And after that, like access policy, so we need to give like access policies to Azure Databricks and Azure Synapse Analytics. So we're going to enable all these three things, and to give an access policy, just click on add. And it's a demo, so we will give everything, but in real world, like it will be depending on your use case and privilege, who is accessing it, and all those kind of things. And then you select the principal and you search for Databricks. So we'll search for, like you just type Databricks. Oh, sorry. You search Databricks, select, add. It will add Databricks, and we need Synapse Analytics too. So we're giving the same permissions to Azure Synapse Analytics. You click on, you click on select. For Synapse Analytics, there is like no, for Databricks, like we just type Databricks and it's available there. For Synapse Analytics, you have to literally provide the name of your workspace. So in my case, this is Data Tech Workspace. So you can select that. So when I say workspace, you guys can see here, this is my workspace name. If you look at this URL, you can see Data Tech US, that's my WS, that's my workspace name. So you need to select add that and add, and you will see like we have given access to both Data Techs and Databricks. And if you want just like not want, like after that you just click on review and create, it will be done. I'm not going to do it as I already have an existing key vault services, so I'll go and show you there. So once you have, once your Key Vault service is created, or workspace is created, and we have given permission to Databricks and as our Synapse Analytics, we're going to add secrets here. So once this will load, you will see I have few secrets already existing. So these are not very intuitive names. I'll say use some better naming convention. This is for demo, that's why these are not very good naming conventions. But basically what it is, it's this is the blob access key value, this is the data lake, this is SQL password which we added at the time when we created the Azure Synapse Analytics workspace. This is the username, and this I'll show you when I create a Databricks. So how you add secrets to your Key Vault, just you click on secrets, then name the secret. So for example, let's say it's this is a secret to access our Azure Data Lake Gen 2. So I'll give it a name, ADLS, and the value for this, if you want to access Azure Data Lake, so that's going to be through the key. So for that, what you need to do is, okay, let me copy paste this again. Okay, let me go to home, storage account. Okay, so this is our Azure Data Lake Gen 2. So click on this, we explore, go to access key, click on show keys, copy this key, go back here, and so this is our key to access Azure Data Lake Gen 2. And similar way we can do for blob 2, which is also same. I've already done it, but I'm showing you how, from where you get all these information. Sorry, it's here. Go to storage account, blob, and it's the same process. You go to access key, show keys, copy, paste it here, and a new secret will be created. Okay, I'm not going to use these two, but it was just to show you how to create secrets in Azure Key Vault. So these two and these two are same. Like this one is for data lake, this is for blob, and these SQL username and password, I hope you guys remember your username and password which you created, which we filled while creating the Azure workspace, Azure Synapse Analytics workspace. Okay, and the process is same for them too. If you go here, I already created, but that's the way you create them. 1 second. It's same. You go here, name the username or whatever is that, username, and you pick your naming conventions. Don't go with mine. As I mentioned earlier, these are not very intuitive or not very smart naming conventions, or whatever is your admin or whatever is your value, just put it in and create it. So but by now you will have 4, you know how to create it, key value vault, give access to Databricks and Azure Synapse Analytics workspace, and also you should be able to add 4 secrets till now. Okay, so next step is let's go here, we're going to create a Azure Databricks workspace. And for that, it's a very simple, it's a simple process. You click on create, and I already have, but I'm going to show you as we are doing here. It's also very simple. You just need to pick your resource group and whatever is the name you want, data tech, DB workspace, or whatever it is. You can click on review and create, it will validate, and once after you click on create, it will create it. So once your Azure Databricks is created, let's go here, workspace is here, we'll click on launch workspace, And once we click on launch workspace, like in your case, you won't have anything. Like in my case, I already have a cluster and a notebook there. But in your case, you won't have anything. But it will look pretty same, except this recent tab will be empty for you. So what you need to do for first step is like, we want to integrate our Azure Databricks with the Azure Key Vault. So to do that, the first step is like in your URL, copy this and keep it exactly same, like it's case sensitive, like scope as is capitalized. So copy hash secrets / create scope and add to the end of your URL of Databricks. So this will take you to a create secret scope. This is basically we are configuring our Azure Key Vault into Azure Databricks. So give a name, whatever name you want, Azure like Data Tech Key Vault or whatever. Like that's the name you're going to use in your code. So, and after that, all users, and these two things we will grab from Azure Key Vault service. So we'll go here, we open Data Tech Key Vault and go to the properties and Vault URI and resource ID. These are the two things we need. So you copy paste here, put it here, same thing, you can copy paste here, and so these two things, and you click on create. So after that, your Data Tech Key Vault secret scope will be created. I'm not going to create it, but that's how you create it. Once you have your secret, like you can like literally can import the code and working on it. Okay, so I'll show you that. But before jumping there, you remember like in Key Vault, we have one more. One second, if I go to secrets, there was like one secret which I said like I'll explain once I have Databricks now. So this is a secret from to access Databricks from Synapse Analytics. So to do that, like you just need to click on this, use a setting, and then create a token. And then you need to provide the comment like this token is going to use for what, and this token have a lifeline of like 90 days. So like simply you can put the snaps and click on generate, it will generate, and this is the token which I have stored here in our Key Vault. And this Key Vault you will see further down the video, like further in the video, that we're going to use in our Synapse workspace to access to run Databricks notebooks. So you understand these two things. Okay, let me go back. Yeah. Okay. So the next step is if you look at our pipeline, we have this thing is done, secret management is done. The next step is we're going to build this first piece of our batch pipeline. So we have like as I mentioned earlier, like we have two pipeline. One is which going through Databricks, and the other one is going through the Azure Data Factory or Azure Synapse pipeline. So we'll look into the Azure Databricks first. So this, as we know, like in Databricks, is like a code environment, like we're going to code it, and Azure Data Factory where we're going to, it's like a no code or like less code kind of environment. So in Azure Data Bricks, I've already imported that, and I'm going to upload this notebook data brick processing. That's not, as I say, it's not a good name. Okay. Oh, even before that, you need to create a cluster, and creating a cluster is very simple. Just click on create cluster and give it a name. Click on create cluster. I'm not going to do it. I have it. Like I already have data engineering, but you can create as many cluster depending on your requirements and all those things. So now we have our workspace, our scope is defined, our cluster is ready. So now we'll look into the notebook. Okay, so I'll explain the logic first, and then we'll look into the code, like what we are doing exactly there. So basically what we need, we want to access the data which is in the Azure Data Lake Gen 2. Main in like there were like three data sets. So you saw branch, regional, and customer. In this case, we're going to consume regional and the branch data in Databricks, and customer will handle later through Azure Data Factory or Synapse pipeline. So what we will like how basically Databricks work, like Databricks going to mount that that folder of data lake, and then we going to connect to our then we also going to connect to our blob storage, because that's where we need it. Like whenever you are writing from Databricks to Azure Synapse Analytics dedicated work, you need it's done through Polybase, and which need like a temporary place to copy paste all the to perform copy activity. So that's why we need a blob storage, and we need like a JDBC connection to dedicated SQL pool. So one is like you're going to mount your Azure Data Lake Gen 2 folder, that's the source folder, and then your blob storage, which is for basically for your temporary storage, which is required whenever you're doing Polybase activity from Databricks. And the last is to connect to dedicated SQL pool, you need JDBC connection. And all these things are like, I won't say readily available, but like if you search it out, like it's very simple to find. So here I kind of created a dynamic code. When I say dynamic, like I'm not using, I could have used like these things not as a variable but directly, but here just to make everybody's life easy when like I'm going to upload this code, and if you want to reuse it, or so in that case you just replace storage account and the container information and you're good to go. So basically we are storing our information in storage account and container, and after that these are the like blob endpoint, and this is the location where we're going to mount, and this is the configuration key which we are using. And this is like a dbutils is like the function of Databricks which we are using to mount. And here you can see that we're using this function dbutils secrets get, which will fetch the secret information from our scope. So remember we created, like I showed you a scope. So in my case the scope name is data tech key vault 2, and these are the key names whose value, or I can say these are the secrets whose value we need. So, and with this code, like I already mounted it, but if you once you mounted it and you want to you rerun it, it will give you an error that it's already mounted. So I'm not going to execute this, but after that, like the next piece of code is basically is to like this is basically blob storage, and like how we can map how we can use the blob storage container as a temporary directory. And here also we using this dbutil secret get to get the key value of blob storage. And similar thing we are doing for the Azure Synapse Analytic Data Warehouse. Like literally you can we are defining variables and storing these values. So in like for you just need to keep in like in DW like here like I'm kind of like using them as a variable, so you just need to replace these values with your variables. But in this case, like I want to point out, like in line number 12 you need to be a bit cautious. Like whatever is your Azure Synapse Analytics workspace name, just replace that with this first piece and you should be good. Your username and password, which you already getting from your scope database. In my case, as I mentioned, my dedicated SQL pool name is EDW. You can have your own. And after that, I'm just creating a JDBC like a URL which will be using in our in our code further. So these are the two main things which you need to, like, how to mount. This is a code which I got from Azure documentation only. I just kind of I didn't modify it much, but the few things are modified where like you can store your variables, and similar thing for JDBC and blob storage container. These are all from Azure documentation. And if you're not sure like how to connect, or how, like, if you are not understanding this thing or it look complex, you can like literally go to your, one second, you can go to your Synapse workspace, click on this. I'm just showing like how I grab these things, and EDW. And if you go click on this show connection strength, so it will give you like how you can connect through .NET, JDBC, ODBC, PHP. So if you go to JDBC, it's pretty much like I have the similar string here too, but it's more dynamic. That's how like things need to be done, but you can literally grab it here and insert your password and you should be good to go. And after that, like I'm just reading those JSON files. One is the branch and the other one is the manager or relation manager. So you can see like this is our mount path, and I'm reading them. If I rerun it, like it should not be a problem. I can okay, my cluster is down, but like waiting cluster, so you can rerun it. Cluster will take some time, but it's already ran, so you should be understanding it. This is basically we storing our, like we are reading our JSON file into branch data and relation managers data. And after that, like we doing just creating like a temporary table and displaying the data, and you can see like some branch information is missing, so we'll do some transformation. Here I'm using a magic SQL recipe where this is very simple, like it's not very complex. Here you can see I just renamed the couple of columns, and after that I'm just using case when to fill like empty branch names. So basically what is like wherever the branch name or branch name doesn't exist, or the logic is where the length of the branch name is 0, simply add like concatenate branch location and the branch ID. So if you see, you look at this, so branch location and the branch ID is concatenated. This is the transformation I'm doing, like nothing crazy. As I mentioned, it's a dummy data, so it's basically, if anything, so we're doing simple stuff with it. And after that, like same thing, like we don't need this. This is like more like when you are not 100% sure, you want to see like what will be the output, you can run this way. Otherwise, like if you're sure, like just run your query and store it. Like now your data is in branch data frame, and after that we just writing that branch data into data warehouse. And here you can see that one second, let me remove these two lines. So here you can see that like basically and this is also available in Azure documentation. We are writing the branch data, which you guys, if you are working with the Spark, you guys have seen it a lot. Like you're writing the data using this driver, like Spark driver. This is the URL which we set already. These are the some options which we need to set, like this need to be done, or if this is not using, there is another option which we need to set it to true. And after that, this is like what is our table. So we are using it's a small table, so like I'm using replicated distribution. If you remember from partition and distribution, there was like 3 types of distributions, so I'm using the replicated one. And this is our indexing, which our compression we are using here. And this, with this name, the table will be stored, and I'm using overwrite, so anytime I rerun this code, it will be overwrite. And similar kind of things I'm doing with the relation manager too. They're also like, it's not very complicated, simple case when statement. If something is missing, just replacing it with like first name or last name, something like very simple stuff, like similar kind of activity. So when I execute these two, it will create two tables in our dedicated SQL pool. So I've already ran it, so I'm going to show you. If I go to our Snap Studio workspace, this is my EDW dedicated SQL pool. If I expand my tables, so branch and relation manager, the both tables exist, and they have the same branch ID, location, date created, same thing for relation manager. And I'm going to upload this code to a GitHub too, so you can use that. For data, I might just upload like few sample files because there is a limitation of loading the data. There is a limitation on loading stuff on GitHub 25 MB. So like after execution of this, this is our like I'll say one step. This is not like a pipeline. We need to need to insert this into pipeline so we can run it at certain hours or certain time. But this is like the step one to creating a transformation or processing in Databricks. Okay, so I'll show you how to ingest a Databricks into a pipeline in a second. But before that, let me jump to our Markdown and see what's the, yeah. So next thing is to create our customer and watermark tables. Okay, one second, let's go to, we go here, tables. So now we have branch and regional manager tables in dedicated SQL pool. Let's create customer table in EDW using SQL. When I say customer table, like it means like creating the schema of it. So if I go to develop script customer DDL, click on this, and here we just creating the structure of the table, but we're going to load that using the Azure Data Factory. Okay, so here you can see in the first few lines is basically if an active schema is exists, it will like drop it. Then I'm creating a schema with the name of active, and after that, like this is the how I create the customer acquisition data table, where we have customer ID, relationship manager ID, last update, deposit amount, and it is distributed using hash. The other two tables are distributed using replicated, and they all are clustered column index. And I'm going to upload this too. If I rerun this, like it like I already have the table, so I'll get an error. But this is basically we're creating a schema and we're creating a table here. And also, second thing, we need the watermark table here too. So the watermark table base is used for incremental load, but we're not going to discuss them in this video because it's going to be too many concepts in a single video, and potentially it can confuse some folks. So they're going to be a separate video on it, but we need watermark table here to load the data because we are loading the data from multiple files. So let's create a pipeline which populates the customer table. So to do that, we need two integration data sets, or before that, let's create some link services. So basically we need 3 more link services than existing one. One is to the Key Vault, Databricks. These two are basically for the Databricks things which we already done, and the blob storage. So I'm going to create new. So I'm just going to show you how to do that. Key Vault, continue, and let's name it ls2. Okay, select the subscription. This is my subscription, and this is my key. test the connection. Successful if you click on create. So this will create a link service to Azure Key Vault. We're going to use that in a while inserting our Databricks notebook into the pipeline. But that's one link service we need. The other one we need is the Databricks one. So click on new. I'm just showing you how to create Databricks. So Databricks, continue. Let's keep it the same name, same thing. Select the subscription. The workspace, we have only one workspace. Then use existing interactive cluster. Then switch it to Azure Data. So here we use Azure Key Vault, and this, and the service name for this was, if you remember, we created a service name here. Oh, sorry, Databricks something. This service, we're going to use this service. Copy, secret name, data engineering. This is like my cluster already existing, and then you can, yeah, that's all we need. So we need like a name, then we need to pick our subscription, database workspace, and then we're going to use Azure Key Vault here. This is our Key Vault work service, link service, and then this is, and then you can test the connections, and it's successful. And after that, you can create it. And I'm not going to create. I already have a blob storage. Is going to be the easiest one. You don't need much for it. Blob storage. Continue. Name, and after that, you just need a subscription and which storage account you use. So we have this. And test connection. Simple, sweet. So now if we look at this, like these two are by default ones, we created 3 new link services which we're going to use down the line. Okay, let's go to the pipelines. So far we have created 2 tables from Azure Databricks and store it into dedicated SQL pool, and we have created an empty file. Not empty, like I've created an empty table in SQL pool for customer, and the other regional and relational branch and regional managers have been populated using Databricks. That's we have done so far. So for customer, I've already created the pipeline, but I'm going to create a new one so you know what we're doing here. I'll name it pipeline customer 2. Okay, and so we're going to use a lookup activity here. So we drag and drop lookup activity, give it a name. This activity like get date list. No, sorry, like before doing this, like we need one more thing. Let's cancel this. If we go to link services, so first we need to create 2 integration data sets before we create any pipeline or anything else. Let me close all this. So let's do this. So now what we're doing, we're trying to create we're trying to populate the customer table using Azure Data Factory. So for that, we need 2 integration data sets. So the first thing we need to, like I already created them, but I'm going to redo. So click on integration data sets. So the first one is the data lake. Data lake gen 2, continue. it's a JSON format. So you first select Azure Data Lake Gen 2, then JSON format, continue, and select the service and the name. So let me give it a name, customer underscore JSON. Okay, click OK, and after that just click OK. Okay, now the next thing we need to do is we need to define 3 parameters here. So these 3 parameters going to be container, like you can have whatever name, but like this I feel like these are the most. Container, container is users. Okay, new directory name. So this is like we creating parameters, so we don't, instead of like hard coding the values, we creating parameters so we can use these to ingest data from each file. So it's going to be data, once again I should have this value somewhere. Yeah, it should be something like this, data customer. So this will be the parameter, new file name should be this. Okay, so we connect, like for this integration data set, we first search for Azure Data Lake Gen 2, select JSON. Now we pass creating 3 parameters, and now we go back to the connection and click on this, and we dynamically add these values. Container. Okay, once again I think in parameter we didn't give it the name to the first one. The last one, it's file name. Okay, directory name, and for file name we need to concatenate, because if you remember in our parameter I didn't give JSON, so for that's why we need concatenate function. So we have to search okay, concatenate function, so where we doing file name comma dot JSON, click OK. So we pass the parameters now, and to see if this integration datasets is working, we should click on preview data and click OK. Awesome. So you see this link service integration dataset is working. We are able to see the customer data. Okay, that's our first data set. The next one is going to be our you click on this again, integration and dedicated SQL pool. We're going to use them in our pipeline, that's why I'm creating these 2, and let's give it a name, dedicated EDW, and you pick the table, the customer acquisition table. Click OK, and you will have, that's it. So you need to create 2 integration data sets. One is to the like a data lake gen 2 with parameters. The other one is the customer table from Azure Synapse dedicated SQL pool. Okay, once we have these 2, let me close, like I'm discarding them because I already have these 2. So click on this, discard them. Now I go to the pipeline, I'll create a new pipeline, and let's give it a name, pipeline customer 2. Okay, so here we're going to look for the lookup activity. So lookup activity, we're going to put it here. So our first activity is the lookup activity, which is basically in this case returning a result of a query, but it can be used for other things too. And the output of this lookup activity, we're going to feed it to our next activity. But basically what we doing here is we taking a result from this lookup. Like we just using a query here. So what our query do is let's give a date list to us so we can iterate over it. Okay, go to setting and customer data. Let's do this. So I have that ready. If I go here, this is the lookup. Okay, let me explain you this lookup, what we're doing here. So you remember the watermark table we created? So basically we are getting one start date and end date. The start date is going to be the January 1st to 2021, because that's from where data started, and end date will be like today's date minus 1 day. And after that we just kind of creating some, how do I say this, like once you see that, like we creating a record for each customer file name and each directory. So we're creating a table which will have a customer file name and a customer directory, like sorry, the directory and the customer file name. You will, once you see the output, you will understand this thing in a better way. Okay, so if I go here and let's preview the data. Okay, so you seeing here, this is the last update time and this is the customer file name and the directory name. And now I know, like, you're seeing only one record. That's because we by default it's the first row only. But if you preview this data, so for each day we have the file name and the directory. So we're going to use this as an output in our next activity, which is going to be a for each activity, and where, like, for each record, the for each activity going to run few things, and in that way they, like, the data will be pulled from one file to another file. Hope this making sense, not confusing you. So what's the next activity we need to do? So we need to bring the next activity is for each. So for each is basically the same thing as a for loop, where, like, you iterate over a code again and again. Here we are not doing through a code, but here what activities exist within for each, you will iterate over them. So here we can say that for each date, okay, and setting, we want to go it sequentially. We don't want to go it in parallel, because we want to iterate over one record at a time. And here we will, okay, cancel once again. And if you go to setting, sorry, dot value, click OK. So that's what you're doing. You're basically ingesting the output of this into for each, and for each record you want to iterate what's in this, what we're going to define in for each date. So what we're going to define in for each activity, for each date activity, is two variables, like set variables. One is for the file name and the other one is for the directory. Okay, and let's give it a name. I have, and 1 second. Yeah, oh, so okay, before we set these two, we need to define two parameters here, like two variables here, to the pipeline, not to the to these activities, but in the pipeline. So there will be, and these are the similar like variables as we define in our code, if you understand coding. So here we define two pipeline variables, data dir, and we initialize them with a value, and our initialization value is same for both cases. Not, I mean, both cases means like what we did in integration data set, and here, and new, we'll add file name, go back here. So in our upper pipeline, we are defining two variables and assigning them these values. So first variable will have this value, and second variable will have this value. Okay, go here, Control V. Okay, now we can go into the activity, and here the first activity is, let's say, set dir, and variable, which variable? Data durable and dynamic. So we don't use this. Instead of that, we will use items, because we want to iterate over each item. So we'll use something like this, which make more sense to you. Means like if we want to iterate over each item. Like if we don't want to look at just the value of the data. Those were the initial, like I'll say, those are the initialization of what we did outside, but we want to like change it every time. So click OK, and same thing, we have to set, let's say, set file name. Okay, go to variables, file name, again dynamic, click, and sorry, we go back here, we want to iterate over file name 2, so do this, click OK. Okay, so now our two variables are set. For each iteration, the directory name and the file name will change as soon as we, like, if you remember from our lookup table, like each record have, so the 1st January, the file name is related to 1st January, and the same with the directory. For the 2nd January, it will change. So these two variables will change according to that. And the next step will be is a copy activity. So in copy activity, we'll bring copy here. Oh, let's make it more. Let me do this, and let's reduce this. So let's make it more visible. Okay, so we feeding these two to copy activity, and in copy activity, let's give it a name. Copy, like let's say CP customer data, like just it's an activity name. So source will be, our source will be, once again, if I go up, our source will be Azure Data Lake Gen 2. So you remember this integration, so we'll click this, and here, if you remember, like we set up the 3 parameters there, and we initialize them with some values, but we don't want, like, so we have to change them. Now what are we going to put? Like container won't change, container remains same, so that's a consistent. So we're going to use data directory variable, and same here, file name variable, and after this, let's preview the data. Click OK. Boom. So we are able to connect to data. And why I replace them with a variable? If you don't replace them with the variables, like it will copy only the 1st January data. It won't, like, for each and it will copy the 1st January data for each iteration. So that will create so many duplications of 1st January. So you need to replace with the variable. So every time, like, your directory and your file name change, you have to replace it. And sync, in our case, the sync will be customer data set. And we have to use polybase. Rest of the things can remain same. In mapping, you can import schema if you want. You click on import, click OK. So it will import the schema and setting, and here you can enable staging, and in staging we can go Azure blobs, and you can literally select a folder where you want to stage, and yeah, perfect. So that's all you need to do, and after that what you need to do is you just need to debug it. Once you debug, like I start running it manually, you can add a trigger if you want. Like you want to trigger it now, you can do that. If you want to debug, like just to see if any errors are, we are in the live environment, so debug will like literally we like it will populate the table. So this is how you're going to populate the data from multiple files into a dedicated SQL pool. Okay, I'm not going to run this, like I already have this, and I ran for a bit, like I stopped it, but like I guess I completed one iteration or something. So if we go into workspace and go into tables, like our customer acquisition table, if I do this, you will see some data is already there, and I can check, like we can do one more, like a quick check. If I do count star from, sorry, so it has some data. I ran the pipeline for a while, not for too long, but like I tried it, so it should have 1300 something. Okay, 1327. So if I go back here and run this pipeline again, let's say debug. So when I click on debug, like it's checking, but as I mentioned, we are in the live Synapse live, so it will populate the data. So it's still in the queue. While it's in the queue, let's look into the other dimension, the other pipeline, and which is basically running the Databricks thing, which like Databricks notebook which we created. So I'll show you very quickly how to do it. And it's very simple. Like let's create a new pipeline, click on new, let's give it a name, Databricks. Okay, and just what you need to do is, you see Databricks, bring the notebook here, whatever, if like you want to rename it, otherwise keep it the same. Go to Azure Databricks. We already, this is where like you remember, like we created 3 linked services, so this is where you select the linked services, and in setting you go and select, you can browse to the notebook, which is, it's in our shared, I believe. Yeah, one second, double click on this, it's in my shared, so this is the data processing. You click OK, and that's how you, it's a simple like pipeline. It doesn't have, and these 2 pipelines are different from each other. When I say different, like they're not dependent on each other. So that's how, like in real world, it's not like each pipeline has to be dependent on others. Like you have to create multiple pipelines, and they may or may not be dependent on each other. Okay, let's go back here and see, it's still running. So like you can see, for a few iterations we have success. So if I go back here, I should have this, so I should have more records now. If I do this, run, yeah, you can see now we have 3,965, and it's still running. Like, so it will like it's just keep updating. So that's all for this video. I know like it's this video have a lot, but if you practice all these things together, you will understand like how like multiple services work together, and how you can build pipelines using different things. And in this, and what we learn here too is like how to populate dedicated SQL warehouse from Azure Databricks, and even from Data Factory. And the other thing is like how to populate a table using Azure Data Factory from multiple like a multiple file sources. So it's a lot, like it will take a while. That's why I created like a markdown for it, like what need to be done. I'm going to upload the these like notebook and the DDL and all those things. So practice it, and once you practice it, and you will see a holistic picture like how these things work in together, and creating a pipeline will be much easier for you. In today's video, we will look into the incremental data load and how to implement it in Azure Data Factory or Azure Synapse pipeline. And it will cover these two topics, like design and implement increment data loads and increment load using the Azure Data Factory from DP203. So who don't know what is incremental data load, it's a pattern to identify the data that are created or modified since the last time the load process run. In simple words, basically we are trying to load only new or updated records from the source. So that is known as incremental data load. Some benefits of it: the first one is it runs faster, and because instead of like full overwrite, we are doing the data load on delta, so we are processing less data, or you can say we are touching less data, so it runs fast. And incremental data load performance is steady over time. And like if we think logically, that makes sense too, because we are just updating, like we just loading the new or updated records. And if we look on any frequency, like a daily, weekly, monthly, they will be pretty consistent. While in case of full overwrite or full overload, like every day the data will increase, or like every time you run it, like it's like old data plus new data. So our load performance will decrease over time. And the last one, like it can preserve the historical data. So many source systems like purge their historical data periodically, and so in case of like incremental load, we don't have to worry about it. However, it's a problem in a full overwrite. Like if you're doing a full overwrite and they purge the historical data, so next day you'll lose everything. But in case of incremental load, we just keep adding the new data, and historical data is already exist in our storage, like it could be data warehouse or data lake. And now let's look at the logic, like what we're going to implement. So here's the logic of incremental data load into the Data Factory or Azure Synapse pipeline. It is very simple and easy to implement, but please keep this thing in mind, like it's not the only way to implement it. Like same logic can be used in like different services, for example, like Databricks and all those places. But and as I mentioned, it's not the only way. There could be other logic to do the same thing. So it start with like two simple lookup activities, where like in the first activity we get the last watermark, and in the new one we get the new watermark. And then after that we copy or load the data into the sink using the like a load logic. That's basically the data between these two watermarks being copied from source to destination. And the last is the store procedures to update the watermark for the next run. So now let's jump into the demo. Perfect. So we are performing this demo in Azure Synapse Analytics, which we already aware, like it's a service which have all the features of Azure Data Pipeline, Databricks, and all those things. So that's why I'm doing it. And the prerequisites is Azure Synapse Pipeline, and also we need to create a dedicated SQL pool here. Okay, cool. So far, if you look into the tables, like I refresh it, we don't have any table. And so we're going to create two tables here. One is the watermark table, and the other one is the source table from which from which we will use the data to load into the our sink. And in this case, we will take our Azure Data Lake Gen 2 as our sink, which is already linked here. Like if you click here, it's already connected with Azure Synapse Analytics. Okay, so let's first create those two tables. Okay, this is EDW. So I already like have script ready where I'm just creating these tables. So first table is named as data source table. Let me copy paste here and explain to you. Okay, perfect. So if you look at the code, like we creating a table named data source table, and it will have 3 fields: person, name, last modified, and their data type. Very basic stuff. And after that we are inserting 5 rows into it, and this is going to be our source. And we, after our incremental row, our data pipeline, it need to be copied into Azure Data Lake Gen 2, or you can use blob storage or some other storage, but in this case we will use Azure Data Lake Gen 2. And so let me first create this table, run. Perfect, the table is created, and after that I'm inserting 5 records in it. Okay, cool. So everything is done successfully. Let's look into the table, refresh, table exists there, and if I do top 100, and so we have all 5 records. And I know I did it like separately, but if you want, like you can do the insertion in one go. Like let me show you, like you can insert things like this too, but keep this thing in your mind. If you're using any keyword or something, don't forget to put it under bracket. If you don't put it under bracket, you will get an error. Okay, so next step is to create a watermark table. Okay, and let me copy this stuff here from here. And don't worry, I'm going to share the link of the GitHub in the description, so you can do this by yourself. You can practice by yourself. So here you can see our watermark table. Okay, yeah, no, it's good. So we are creating a watermark table which have a table name and a watermark value, like our other field is watermark value, which is date time. So we're going to create this, run. It's running, that's successful. And after that we just inserting 1 record, and this is like you can see, like I inserting like a January 1st 2010. So this is because we don't have anything in our table so far, so we can pick a date from past which we know that we haven't inserted anything. So I'm using this, but generally, like if you're starting something for first time, like you can literally use this 999, this kind of thing. So you know that, like if like in your watermark table, the watermark value is 1/1/1999, like it means like it never been there was like no incremental load ran so far, so this is like never been used. Okay, let me do this. Okay, so I inserted 1 record, and you can see 1 record exists there. And now we have our watermark table and our source table. So next thing is, like we can directly jump into the pipeline and create the logic we talked about it, like this thing. 2 lookup tables, 1 copy activity, and the store procedure. Oh, sorry, before jumping there, let's create the store procedure too. And it's going to be a very simple store procedure too. If you copy paste, come back here. So if you look at the store procedure, it's 1 second, let me increase the screen size so you can, yeah. So let me create the store procedure and I'll explain this to you. Okay, there's some, oh, so sorry, my bad. Like I already created the store procedure, so don't that's why I couldn't create it. But like to show you, let me do one more thing. We can do one thing. Let me go to second. So I'm dropping the old store procedure just to show you, like, and next this got this. And if I run this, yeah, perfect. So like I just dropped, like I forgot to drop the old procedure, and after dropping, like everything works fine. So in this stored procedure, you can see we are creating like a stored procedure with name of USP write watermark, and these are the two parameters we are passing here: the last modify time and the table name. And this, like in our activity, like in our data pipeline activity, we have to pass these two values to run this stored procedure successfully. And what are we doing? Basically, we are updating our watermark table with, like, we are updating the watermark table, basically both values, watermark value and table name, whatever parameters we pass, it will be set to those new like new values. So basically watermark value will be set to the last modified time, and table, where like table name, which table name we passed here, which we will pass here, will be set to that. So it's easy, and like it basically updating the watermark value in the watermark table for the table which we passed as a parameter. Okay, now let's jump to, so now let's jump to the Azure Synapse pipeline to build the pipeline for our incremental data load. So first click on integrate and then click on the pipeline and name the pipeline. So I'll give it incremental load pipeline. Load, I'll give it a name, then I collapse this. Okay, and if you remember from the logic slide here, we need two lookup activities, one copy activity and then stored procedures. Okay, so okay, let me come here and search for the lookup. Let's bring two lookup activities here, and in I have the naming convention ready, so I'll go to my GitHub and pick the naming conventions I want. Okay, copy paste. Okay, so this one second, let me expand this. So this is the old watermark activity, and here in the settings, if you go like you have to click on new data source if you already haven't linked service. So we'll click here, search for Synapse dedicated pool, click continue. Let's give it a name, SQL2 table, and we select our dedicated pool and the table. So here we're going to select the watermark table, click OK. So our old watermark activity is done. Now we have to set our new watermark activity table. So we go here, pick the name from our GitHub and go back here, expand this, rename this, and for this we will use the same link service, but instead of a table, we'll use a query, and this is the query, which is very straightforward query, where what we are doing, we are basically picking the maximum modified time as a new watermark value from source table. So now our lookup activities are ready. The next activity is the copy activity. So we search for copy activity, bring it here, and let's give it a name or keep it like to the default. So first thing, we need to set our source, and if you following the video, the source is the Azure dedicated SQL pool, and sync will be our data lake gen 2. So for source, click on new and Synapse dedicated pool, click continue, and 1 second, we can discard this and we can use this, and we need a query here. Control C, go back here, and let me explain you the query, which is pretty much we talked about in the slide. So basically what we are doing, we are taking all the records from data source table which are greater than the last which are greater than the old watermark value and less than and equivalent to the new watermark value. So anything in between these two values will be considered, all those records will be considered as source for our sync. And here we're good. Now let's go to the sync, click on new. We're looking for Gen 2, search for Gen 2, click here, continue. You can go with the data with the like a file type you want. I'm going with the delimited one, but you can go with the JSON, Avro, Parquet, whatever it is you need. But for this demo, like dedicated pipelines should work. So I remove dedicated time to pick this link service, and this is the default link service. As we know, Azure Synapse Analytics, when we create a Azure Synapse Analytic workspace, there is like a data storage is by default connected or mount to it. I'll say connected. So this is the default service, and then we go for user, go here. So this is user is our file system name, which was given during the creation of workspace. And here you can see there is one file already existing, but I don't have any other folders to store. So I'll use user as a this file system as my storage, and I'll click OK. There is no directory, it's directly user, and then the file, click again, click OK. And for the file, I'll do one thing. I just need to do that. I'll add a dynamic value to it, and which is just to like it's a straightforward simple one, but why we doing it? So we know like for each incremental there is a like a new file. So here you can see it's a straight concatenate where we taking a like a string, which is incremental hyphen, and then adding the pipeline run ID followed by .txt file. So click OK. So when our pipeline will run, we should see a new file with the new incremental pipeline run. And here we are good. Okay, let me with this. I'll go back to here, do this, and we are using the output of our like old watermark activity and the new watermark activity. So we have to connect this to this. Oh, sorry, connect here. And the last activity, if you remember, is the stored procedure. So there are two stored procedures available. One is general and the SQL pool. In our case, we will use the SQL pool. If you remember, we build the stored procedure for watermark in our dedicated SQL pool. So I'll grab it to the canvas. I expand this, go to settings, dedicated pool, EDW, and stored procedure is this. And in our stored procedures, we were using two parameters. So now we have to import those parameters. You see stored procedures parameters, so we have to import them and assign some values. Here you can see we imported both parameters, last modified time and the table name, and now we have to set values to them. And if I go back here, these are the values which we need to set, and let me explain them to you. So here we are setting the new watermark value as the last modified time. So whatever is the output of the new watermark activity that was assigned as a new watermark value will be aligned to the last modified time. And for the table name, we are using our old watermark activity and assigning this here. Okay, cool. So we good. And now let's connect this to this. Perfect. So our pipeline is ready, our incremental pipeline is ready, and we will revise one more time. So we have a old lookup watermark, new watermark, then a copy activity where we're copying from our source to sync, and we are copying only those records which are in between our old watermark and the new watermark. And in our sync, we added a dynamic file name there, and in the end our stored procedure will be updated. And now I'll debug it. Hopefully it should run, but if not, we will see what is but we'll see what's the problem, but generally we haven't made any mistake. It should run, but in case it not, we'll look into the error. Okay, before that, let me publish this so we don't have any issues, because sometimes what happens if you don't publish it, like it debug also give you errors. Okay, let me refresh this. Oh, publish is completed. Okay, cool. And yeah, let's click on debug. And you can see like it goes step by step. It's a sequential, so both lookup activities are working together, then the copy activity after that, followed by copy and store procedures. So it should not take that long. If you want to see the output, you can expand this and see they both are in the queue. And oh, perfect, everything is ran successfully. So now how we can check it? Now we go to our data and look at the watermark table. So previously the value we set in the watermark table was 1st January 2010. Now it should be different based on the our source. I'll look at the source too. So source output. So if you look at the last modified time is something like it need to be 2017 something. So let's check the output. Oh no, not bad. Go to the script, and if you look, like our watermark value is updated to the last modified time. In today's video, we're going to discuss about the surrogate key. In DP203 exam, there are 2 or 3 questions on it. That's why we're going to talk about it. And topic for today's video is surrogate key and how to implement it using the identity property. So we will do like a demo for the same in Azure Synapse Analytics. For those who are not aware about what is a surrogate key, here's the definition. It's a system generated key in a sequence, or it could be a GUID too, which have literally no business meaning, but that is used, or it is used to uniquely identify a record in the table. And most of the time when we are creating a surrogate key, it is to create a new primary key, or like it is used as a primary key. And then how different is it from the natural business or a domain key? Basically, like as the definition goes, like we can get a meaning out of it. Like, so natural business or domain key have some business meaning, and they are formed from the attributes that exist in the data. It is not something we added after into our data. So surrogate key is something which we add to our table, while natural and business or domain key are those which exist in the table, and they can be used as a primary key too. So for example, a surrogate key is something a very like a literal sequence of 1 2 3 4 5 which have no meaning related to data, where a natural or business key could be a social security number, or PAN card, Aadhaar card, or a phone number, those kind of things. Okay, let's jump to the implementation of surrogate key using the identity property. Perfect. So for this demo, as I mentioned initially, we're using the Azure Synapse Analytics. So I already created the Azure Synapse Analytics workspace and the dedicated SQL pool. So let's first look into what exactly is in the code, and I'm going to provide the link for this code in the description. So don't worry about about the code piece. So if you come from like a SQL background, or like somebody who already worked with the databases and all, you may or may not have seen this, like the identity property. But basically identity property is something which take 2 parameters. The first parameter is the seed, seed is basically from where the sequence starts. So in this case, the sequence should start from 1, and increment is like how we want to increment to it. So we want to increment for each row 1 value. So the first row will have like the value for C1 column will be 1, and the second row will be 2, 3, third will be 3. But if we change this to, let's say, 2, so the first column will be 1, second column will be 3 and 5, something like that. That's happened in the SQL world. But with Azure Synapse Analytics, the identity property does not guarantee, let's change it to 1. Yeah, so but with the Azure Synapse Analytics, the identity property does not guarantee the order. And it's not due to the identity property doesn't work properly in Azure Synapse Analytics. Is basically the architecture, as we know that Azure Synapse Analytics is built on top of a distributed architecture. So due to the that architecture constraint, like identity property does not give you the guaranteed order or the sequence. Still, it will be going to be a different value for each row, but not in the specific order. Okay, let's execute this. So here so if you look at this, like the highlighted section is basically we're creating a table named T1 in DBO schema, which have 2 columns. The first column is the surrogate key, which of integer type, and this is the pattern we want to follow, like it start from 1 and go for and increment by 1. And as I mentioned, it's not going to do the same in Azure Synapse Analytics, but we have to pass these 2 parameters. And second is just a varchar of 30 size. So let's create this table. Okay, the query executed successfully, and after that, if you look, like I'm not passing any, like I'm just inserting null record to both, like null record to both columns, and I'll do the same here. When I say both columns, because like we are not passing anything, so it's we basically adding null record. But if you run this and see the output, so you see, so the column C1, which is the surrogate key, have a number in it, and the second row have another number in it. And as I mentioned, in Azure Synapse Analytics, they won't be in an order. They won't do the exactly which identity property is supposed to do, but still, like they can be used as a primary key because they will be unique. And you can see in C2 there is a null, as we inserted nothing there. The other thing is, like we can explicitly insert value in surrogate key 2, and that can be done by using the identity insert property. So what is needed there, we can see it in the code. Like we need to set this property to on, and after that we can insert to our like columns, like these, like whatever value you want. Like in this case we are inserting -1, but you can insert values which you want. But this is this need to be done in very I'll say in rare cases. Like in real world, it's a kind of slippery road, or it's kind of tricky. Like you might insert a value which already exists, and then you won't be, then like surrogate key can't do the primary, like it won't be a primary key, like it won't be able to identify the each record each like unique records in the table basically. So this is like if you have to insert like a very special values, like a negative value and those kind of things, do it. Like I won't recommend to do it on a production server or something, until and unless like you have a use case for it. Okay, let's run the code from here to here. So we basically would be setting the property on, then we inserting records, setting it off, and then doing the selection. Okay, query runs successfully. Let's see what's, so boom, you see we have another record which have like surrogate key value -1, and it's unknown. Like we inserted literally unknown string to it. So this is how we implement the surrogate key using identity property, and the things which I mentioned, like we need to keep in mind from Azure Synapse Analytics perspective. There won't be a guarantee for the order or the sequence. Okay, and with the identity property, we have some limitations too. Let's look into that. So there are some situations where identity property can't be used. So we can't use identity property with a column which is not of integer or big int type, and that's because of the Azure Synapse Analytics distribution architecture too. Because uh, if we don't, let's say if we use a different data type, there is a possibility all the all the records will will be stored in one particular compute node or storage node, and which will create which will create like a hot partition kind of situation where like too many records are present in one thing and rest of the or you can say like it will create like skewed data. So more data present in one node, but rest of the node don't have anything. And if you're using the column as a distribution key, you can't use like identity property there too. And when tables are external, in that case too, like identity property can't be used. And there is one more, like I didn't mention here, but like if you want to create a table using CTAS, like create table as there also you can't use the identity property. However, you can use the property with the select n thing. And in generally select n and create CTAS, they both work in the similar way. But for identity, like you can't use CTAS. So that's all for this video. And as I mentioned, the purpose for this video is to let you know about the surrogate key, and and there are like a couple of questions on this in DP203 exam. So it's good to have some information about it. And it's mainly for those folks who are not coming from a database or data warehouse background. So this video will definitely helps you to get to answer a couple of questions there. In today's video, we will discuss external tables in Azure Synapse Analytics, or previously known as Azure Data Warehouse. It's a very critical topic. You will find a couple of questions in exam. I got it. Some of my buddies also got it. So uh, don't skip this. So without further ado, let's start. External tables. So the people who already works in the data field, they might hear this term, like they might be aware about this thing or this term external table, and they might be wondering like, is it same as like external tables which we used in Hive or Oracle? So the answer to that is a similar type of concept in Azure. And the people who don't know what is external tables, in simple words, we can say it's a table which points to the data located in Hadoop, Azure Blob Storage, or Azure Data Lake Gen 2. And these external tables can read-write data from these Azure Blob storages, Azure storages. Basically, it's just a logical layer on top of that physical data which exists in those Azure storage of Data Lake or Blob. In some ways it's very similar to View 2. Like View is created on top of a physical table. So basically what happens, like you have a table, you create a view on top of it. Here, instead of table, we creating a like a like a table or like a logical table which points to the data located um, in like some storage. So there we have a table like from a database, but here we are doing it to the files. And if you if you drop the external table, the data still exists in the storage. And same thing goes with the view too. Like if we drop the view, like physical table still exists. So in some ways they're pretty same, but like view point to a physical table exists in the data warehouse or database, where here we are pointing to the files in the Azure storage. If we talk about the external tables, type of external tables in Azure, there are two types. One is Hadoop, second is native. So the main difference, both of them, is the type of data source they are pointing to. So Hadoop is basically for Hadoop related files, like for example, Parquet, Org, and anything coming from HDFS, while native is like delimited type of file types, but not coming from Hadoop or HDFS kind of storage. So Data Lake Gen 2 is Hadoop compatible. So for that, the file type is Hadoop. And the Hadoop file is only like Hadoop external files are external tables, sorry. Hadoop external tables are only available in the dedicated SQL pool, while native is mainly available in serverless pool, but we can they can be provisioned in the dedicated SQL pool too. So next topic is like steps to create external table in Azure Synapse Analytics, and believe me, it's very critical because I got 2 questions on it, and as I mentioned, a couple of my buddies got 2 questions, so they were all related to how to create an external table. So there are 3 steps to create an external table. The first one is creating the external table data source. Second is file format, and third will be just creating the external table. And that can be done by 2 ways, like using a regular DDL or CETAS. So what is create external data source means? So create external data source where we are actually creating, you can think like we creating a link to the storage. And second step where we are defining the file format, like what kind of file is it? Is it Parquet? What file options if it is delimited, what options we need to pick. And in the end, like we just writing a simple DDL, which points to these file storage, like data source and file format. The people who are coming from Hive, they can do same, like they don't have to do all these 3 steps, like they can do everything in the DDL itself. But here we have, for Azure, we have 3 steps. First, create the external data source, which is basically like providing the information to the data, like to the storage. Second is like what kind of file is it. The second is providing information about the file format, and the last is creating the external table. And that can be done through DDL. That can be done through 2 ways. One is like writing the regular DDL, like create external table with column names, column type, like that, and using CETAS. So don't confuse with CTAS, like that's like create table as select, but this is create external table as select. So last step can be done by 2. So now let's jump into the demo and make everything's more clear. Okay, so to save our time, like I already uploaded a data storage. Oh, sorry, I already uploaded a dummy financial transaction CSV file into our data lake Gen 2. So if you go to link, like how if you want to replicate it, like I'm going to upload this file and the script and to the GitHub, and the link I'm going to provide, so you can practice at your own too. But basically what I did is like I go to my linked data lake storage Gen 2, and there I created a new folder raw, and I just uploaded the CSV file there, which is very simple. You click on upload, select, and I uploaded the dummy financial transaction data. Okay, so now we want to create an external table which reads the data from here, basically. So as you remember, the step 1 I was mentioning, like we need to create the data source first. So in that step, we have 2 more steps, I'll say. They're part of that step, and they're not always you have to do it. It depends on like how the storage is set up. If it is like public storage, everything is accessible to anybody, yeah, you don't need to do these steps. So basically the step is so the step, like you need to create a master key, which is basically for security purposes, and the main step here is to provide the credentials. And as I was mentioning, if your storage is public, you don't need this step, this is optional. But here what you're doing is you basically passing the access key, or creating a scoped credential where you passing the access key, so our external source can access, so like our Synapse Analytics can access to that CSV file. So here the format is like first create the master key, which is required for encryption and security purposes. Second is create the scoped credentials. So this, it is very straightforward, like create database, then scope credential, and the name of the scope credentials. And as I mentioned, this is to access the storage. So this, with entity, like here you see, oh, it says shared access signature, so it's a SAS. No, it's not a SAS. Still we using the key, So when I say key, what that means is basically you go to your storage, like you search for your storage account, go to your data lake gen storage, scroll it down, click on access key. So we have two keys here, right? So you copy the first key or second key, whatever you want, and here we're using the key. I don't know the reason, like why this the identity is shared access signature here, but it works with the key. And to create the external data source, the syntax is create external data source and then the data source name. And after that, you need to pass these parameters. So what type of external file is it, or external table it is, Hadoop, and what's the location. So as I mentioned, like data source is basically providing you the link to the to your files. So this is Hadoop, and location we all know we can get it easily. If this is our file, we go here, click on properties, and we can copy Azure blob file path. You can copy this, cancel, come back, paste it here, and then passing the credentials. So we can, this is like pointing to the direction, and this thing is, okay, now you have the access, you can access it. So that is the external data source, financial data data source. So data source is created with the name of finance data source. So next step, if you remember, was to define the file format. So for that also, it's straightforward, like create external file format, then you give the name of the file format. These are user defined, like you can give according to yourself. So based on your naming convention or your organization naming convention, use that. And there you tell like what type of file is it, what kind of format you want. So we are reading a delimited file, it's a CSV. So it's a delimited file, and the format options are, okay, terminator is a comma, and the first row start from the second, because if you know, not like in CSV, our first row is basically a header, so that's why we're ignoring it. If you don't pass it, like it will consider that as a record too. Okay, and the final step which I was mentioning is writing the DDL. So till here, I think like it's very straightforward for anybody, just creating an external table, passing the column name, type, and here comes the things which we defined in our last script. So we pass the data, these are the parameters which we need to pass. So data source, which we created here, second file format, which we created here, and sorry, I will go back. For the location, like if you see here, like we are not passing the whole path. This is basically we pointing to that that storage, and after that we have to pass the exact file location. And you can like even you can pass the folder too if you want to read multiple files. Here I have only one files, but if you want, you can do the same. Okay, let me show you this, like how it look. I've already executed this, but I'll redo it, but I want to show where you can check all these. So if you go here, this, so in our dedicated SQL tools, there are two things: external table and external resources. In external resources, you will find external data source and external file format. Okay, if you expand this, external data source and external file format, as I mentioned, I already created it, and similar thing, I've already created this too. So let's drop these. So I'm going to drop our data source. Let me run this. 1 second, what's the error? Oh, so first we need, like, because it's used by an external table, so I'll first drop the external table. so we can see how to do. Okay, let's go drop. So we're dropping the external table. Okay, now we can drop the source, and we can drop the file format too. Perfect. So if I do a refresh, like, there won't be anything here, and same thing here. Like if I refresh it, no external table. Okay, now if we go here, sorry, my bad, this is script. Let me close these drop ones. Okay. So one thing, like we already created the master key. So if you rerun this, like if you run it once and you want to rerun again, you'll get an error that master key already exists. And same thing is like you already created this scoped credential with the name of ADLS credential. So you'll get an error. If you want to like switch to a new key, then you can create it, or you can do one more thing. You can drop these two too and create it. I'm not going to do it, but just I'm putting that like just telling you guys. So here, like, select this. So this is going to create our external data source. Perfect. If I refresh this, we got it. And same thing, this is going to create our file format. If I refresh this, yeah, we got it. And now if we go here, we can create our table. So this is the final step, and I'm using the regular DDL, but I mentioned like we can use CETAS too, and I'm going to give you one example for that too. Awesome. And now if we refresh this, we got this, and if we do this, perfect, we got the data. It's a dummy data, it's like nothing, not our original. You can figure it out from the account number, check number, and all those. It's a dummy data I'm using. Okay, so this is how, like, this is the 3 steps which we need when we are creating an external table in Azure Synapse Analytics. And the last piece I want to talk about is CTEAS. And if you remember my slide, even if you're doing with CETAS, these 2 steps are required. It's not like these are not required. So just keep that thing in your mind. So here, like, everything's same, everything is pretty same, except like you providing a select statement after that. And we are reading from a file, so open row set as the default way to do it. It's an example. I pick it from the Microsoft document. If I run, it won't run because I don't have this location and these data sources and all, but I just keep it to show you guys like how we can do. So like basically external create table name, then you pass the location, similar to if we go here, this is same. Then data source, you need to create a data source file format, which is same here too. And the things get different is from here, where you actually pass a select statement to create it. So as I mentioned, like the last step can be done by 2 ways, using regular DDL or using CETAS. So don't get confused in the exam if you get CETAS and think, oh, we can't, like, is it correct? Like, is it the right option or not? If it is CETAS, yes, do it. And sometimes they confuse you by giving like CTAS, which is like create table, and that's not the correct option. So in today's video, we're going to talk about the Stream Analytics Windows functions. Some of you will be wondering why we are jumping straight to the Windows function without understanding the Azure Stream Analytics or Spark structured streaming. I realized while creating the window for Stream Analytics that in past I have already created or I already made a couple of videos on these topics. So please check out those videos. I'm going to put the link of them in the description. So without further ado, let's jump to the Stream Analytics Windows function. So Stream Analytics Windows functions are basically categorized into two types. The first one is the non-overlapping, and the second one is the overlapping Windows function. The non-overlapping are three types: tumbling, session, snapshot, and overlapping is hopping and sliding window. So we'll start with the tumbling window, and this is the most used function. I have used that too. So basically here, like, we count the number of, like, we like in this Windows function, we basically do the aggregation on certain time frame. So it is pretty similar to like the tumbling trigger, like, okay, start this job after every 10 seconds. So here in the screen you can see, like, if we have to count like how many records, how many events are actually happened in every 10 seconds, we're going to use the tumbling window. So you can see in the first 10 seconds there are 3 events, and after that from 10 to 20 there is 2 events, 20 to 30 there are like 4 events. And we are using tumbling window in the group by clause. So you can see select count as event from source, timestamp by this, and group by tumbling window. So tumbling window syntax is the time unit and what's the window size. So in this example, the window size is 10 seconds and the time unit is second. You can have other time units too, for example, minute, hour, days, and those kind of things. And as I mentioned, it is the most used Windows function. One thing I want to like bring into the attention, I want to like talk about in this like in the Windows function concept, is this timestamp by. So there was like, I'll say, one question, and a couple of my buddies were confused too. Like when we are studying on like Windows functions, we forgot to like see this thing. Like if you look at this, it doesn't look like normal SQL query, where you can see, okay, if select count makes sense for somebody who's coming from SQL background, you can make sense out of it. Like, okay, so we're doing a count on all the records as event from source and then group by. But what exactly is this timestamp? So in streaming words, there are like multiple timestamps are available. So when I say multiple timestamps, like for example, when the event happened, that is like, let's say, event creation time is there. Then when it is ingested into our system, that ingestion time is there, processing time is there. So based on our requirement, we're gonna put like on what timestamp we wanna create our like a stream functions. So here it is on create time, but basically this thing you need to keep in mind, because like they give a question where like they you have to pick like two you have to fill like 2 blanks, I'll say. So the second, like one blank is about like the Windows function, which when we understand the different types of Windows function, we fill it. But the other one is basically this one, where they literally like either like remove the what kind of timestamp you're using, or like remove this timestamp by. And if we don't focus on this, like we get confused in the exam, like is this the right format or something wrong there. So tumbling window syntax is basically, you can use tumbling window or tumbling with the time unit and the size. It is like we are aggregating something which happened every 10 seconds or after every certain time frame basically. So here's the key, is every with no like no other options available. So if you find anything where it says, okay, give us the number of events which happen every 15 minutes, tumbling window is the option. And the other thing is, like, tumbling window don't overlap, as we saw. So an event which occurred in one window won't be counted in another window. Session window. So session window, the syntax, I'll start with the syntax. So here the syntax is like session window, session, then followed by time unit, timeout size, and max duration size. So time unit, we understand like it could be different units of the time, second, minutes, and all those. Timeout size is basically when the session gets timeout and what's the maximum duration of this session. Here session starts, or like you can say, sorry, here session window begins when the first event occurred. So you can see here the first event, uh, like the window started from here. Sorry, like window started from from this point, not from the zero. Like in case of tumbling windows start from zero, but here it start from there. So basically here windows begins when the first event occurred, and if another event occurs within the timeout frame, so we have a timeout parameter. If other happen within that, then window extend, and it can extend up to the max duration only. So in this example, if you look, the first event happened here, the second event happened here, it's within the max out time, which is a 5 seconds. So from here to here it's like 4 seconds, I guess. But it, so that extends the window, but the window will be extended till 10 seconds only, like in this case till here. If it like if nothing happens, like window close it. Like basically if no event appears within the timeout, window close. So the second window started from here, from the 11 second, you can see, and it goes like first event happened, so then it gets the window extended till next max out, then the like a 40, like this event happened at 15 second, then it's extended again. But even this happened here, it didn't extend further, as I mentioned. Like if event happens within the timeout frame, the window extend, but it extend till the window max duration. So in this case is like 10 seconds. Personally, I've never used Windows function in one of my, like in any of my work. Snapshot, this is quite easy. Basically we're like we grouping the event that occur at the same timestamp. It doesn't require any specific function for it or any syntax. It's basically you group by them system.timestamp, and we can apply, as I mentioned, simply by adding system.timestamp in the group by clause. So here, like let's say it's happened at 1 second, so anything, all the events happen here will be counted. And this is pretty much like you guys, not exactly the same, but you guys, or like everybody who is in the like reporting world, they use these kind of group bys. It's a snapshot window where like anything which happened at the same timestamp, we group them together basically. Next is the hopping window. So let's look at the hopping window syntax first. The hopping window, basically this the keywords remain same, then time unit is pretty constant in all of them except the snapshot. Then there comes window size and the hop size. So window size is basically like how long is the window, what's the duration of window, and hop size, how much window move forward relative to the previous one. So for example, in this case, if you look at this hopping window second, 10 and 5. So the window size is 10 and it is supposed to hop at every 5 seconds. So if you look at this, it started like window started from 0. So window is from 0 to 10. That's first window, and second window will start from 5 to 15. The next window start from 10 to 20. So we are hopping like, so here you can see we have 1 2 3 4 5 windows, and we basically hop means like the window slides that much time frame relative to the previous one. And here, as I mentioned initially, it's an overlapping window, so an event can occur in multiple, like it can be part of the multiple windows. So for example, if we look at here, like 1 6 10, this is our first window, the event count is 3, and the second window, which start from 5 to 15, our count still 3, but we, like 6 and 10 are part of both the windows basically, and same 2 is part of both. 14, you can see that like events can be part of multiple multiple windows basically. And hoping window, it's I've used in one of the use case with Twitter, where it was like kind of in an experiment, like not in exact real work. Hopping window, not hoping, sorry, hopping window. And the last window is the sliding window. With the name, some of you might be thinking it as like a concept of a moving average. The people who works like who do a lot of business reporting, they are aware of moving average. So moving average concept is basically, let's say I want the average salary of last 6 months or so. So it starts from, let's say, from March till September. As soon as we move to October, the average goes from, like the duration change from April to October. It's like by name and look, it look like that, but it's not exactly like that. When we use sliding window in stream analytics, basically system is asked to logically consider all possible windows of given length. So when I say given length, means like 10 second, like in this case it's like 10 second. So every 10-second sliding window system need to be considered. But in stream analytics, if we think, it's like the windows can be infinite. For example, if like IoT device is working and our sliding window is of 10 seconds, like literally after every second we counting sliding window, it could be really like it can result into a lot of windows. So to optimize that, or to not to go into like an infinite number of windows, Azure Stream Analytics instead output events only for those points in time when the content of actual window change. So you can see here, like we started from 0 to 10, then we didn't go from 1 to 11, like it kind of moved here. So when the actual content changed, then only things change. So like here 6 happened at 12 second, the second, like let's say these are the event IDs. So from here to here, first event happened, this is the second event. So our window will be considered from here, not from here. And same thing, like at this point 4 and 5 happen, so they take it like 10 seconds from there. And then after that, like no event happen. And still, like if you taking like 10 seconds from here, you will find these. But like only when an actual event exit or happen, then only sliding window or like Azure Stream Analytics window counted. And syntax is pretty similar, like time unit and the window size. So that's all for this window. So the key takeaways from this window is like types of windowing function, and don't forget to check my old videos on Azure Stream Analytics or Spark Structure Streaming, and this timestamp by too. Like as I mentioned, this is asked in exam. Like I've seen in almost in every exam where people get confused, where like they see a blank of time, like it's like a drop down where they write this query, and in the first drop down they keep it blank and provide you multiple option, and the same like in the second drop down they keep it blank and provide you multiple options. So with Windows, we can figure out like what kind of window they're talking about, but this timestamp, sometimes we don't keep an eye on it. So if you keep an eye on it, that it's helpful. And as I said, this is just basically because in stream, well, like in stream analytics, there are different type of times. So not different type of time, like different times. So which one we have, on which we are creating our windows, that's basically decided by this thing. In today's video, we will be covering Azure Databricks and the topics related of Databricks in DP203. Databricks itself is a very broad topic, but we will be focusing only on those things which are important or critical for the exam. So without further ado, let's start. Today we will be covering the following topics: what is Azure Databricks, the various components of Azure Databricks, types of cluster, and a sample demo of all these components and the Azure Databricks. So there is some prerequisites if you want to understand the Azure Databricks. That is you need to have some understanding of the Spark. If you're already aware about it, that's good. Otherwise, please visit my video on Apache Spark. I'll provide the link in the description. So the first questions come into the mind: what is Azure Databricks? Azure Databricks, before jumping into the Azure Databricks, let's try to understand what is Databricks. Databricks is a platform which was formed by the founders of the Spark, which is basically they build infrastructure on top of the Spark engine, so the users don't have to worry about the Spark infrastructure. So if you understand Spark, like in Spark, you need a cluster to run your jobs. The cluster could be single node or it could be multiple nodes, but setting the all Spark configurations and managing, like if it's a big cluster, like more than 100 nodes in it, like it's hard to manage. So to solve that problem, the Spark founders bundled all those things into one infrastructure and opened this platform named Azure Databricks. And in simple words, that same platform is hosted in Azure, is known as Azure Databricks. And here we are using Azure VMs as a node. Or if you're gonna want to talk, say it in other words, we can say it like it's a data analytics platform optimized for the Microsoft Azure cloud service platforms. And if you want to further simplify, it's basically unified data analytics platform built on the cloud. It's not just Azure, you can find the same thing in AWS too. So it's basically a unified data analytics platform built for the cloud or distributed cloud systems to support various personas of the organizations. The components. So this is important for exam perspective. The components of Databricks are like workspace, clusters, notebook, jobs, and data. We'll see all of them in details in the demo, but we'll touch them now too. So workspace, it's very similar to the concepts of the projects, or when you are building a project in let's say, when as a developer you have your own workspace. Similarly, if you come from Linux backgrounds, you create your own workspace where you work in, and so each workspace is kind of isolated from others. And in Azure Databricks, there is an identifier for each workspace, and everything is deployed in some access control manner for that particular workspace. So if you're working for different teams, or we can think from organization perspective, different teams will have different workspace, or different projects can have a different workspace too. Cluster, that is really important because they asked in the case study questions, they ask about a lot about the clusters. For our understanding, we can say it's at most basic level. In Azure Databricks, the cluster is a series of Azure virtual machines that spin up with the Spark configurations and are used together to unlock the processing power of the Spark. Notebooks, this is web-based, pretty much like Jupyter. It's a web-based interface where you can interact with your data, you can write code and all those. So it's a web-based IE, and it's pretty same like a Jupyter notebook. Jobs which you can like create your jobs which you can run periodically, and data, as we all know, like everything related to data. So when I like why I mentioned data here, like Azure Synapse Azure Databricks can connect to various components of Azure, but they have their own file system too. They call it Azure Databricks file system, which like for a user it seems like it's like a mounted file system of Azure Databricks, but at the back end, like it's just a data lake where you're storing everything, and that data lake is mounted. But like for data, they have a file system which come by default mounted to the Azure, or you can say this is like a managed file system with the Azure Databricks. Cluster, if you come from the Spark background, like as soon as you see this picture, you will understand like like in cluster we have driver node and worker node. Driver node, which basically like our code or program, which like it's a node where we write our code and program, and it tells the worker nodes what need to be performed or what tasks need to be done. So I just want to give you like what exactly a cluster look like. That's why I added this slide, is just to give you a brief idea. Like it's pretty same as the Spark cluster. Okay. Types of Azure Databricks clusters. So there are mainly two types of clusters. Pool is not like a cluster type, but I'm going to talk about that too. So there are like two types of clusters: all-purpose and a job cluster. So all-purpose cluster is mainly for most of the work, like our day-to-day kind of activities, and it have three different types of modes in it: standard, concurrence, and single. So the single node cluster is basically it's a cluster which consists a driver node but no worker nodes. So there is like only one node which is working as a driver and worker both. There are no other nodes in it, and this is like this started very recently, like in 2021. This is for like lightweighted exploratory analysis or any like single node machine learning kind of activities. Concurrency, as the name says, like this is a cluster where like multiple users can do their jobs and like can work concurrently without impacting each other's. Standard is standard is pretty same as the single node, but it have at least one worker node in it, and it is used for like those kind of activities where like you don't need multiple people to work on something, so you can use standard cluster there. So they're like concurrency. Basically, you need to keep in the mind like in what scenarios which all-purpose cluster you need. So single cluster will be for, as I mentioned, lightweighted or very small kind of task. Concurrence is like when you have, let's say you have a good number of analysts, they're working together, like any job where like multiple users will be working together. And for that kind of situations, we go for a concurrency. Standard could be like depending on the use case, but let's say you have a team of 10 people. Out of that, you have only 2 data scientists, so you can have like you can spin up 2 standard clusters for data scientists. And in standard clusters, we will see like we can like we can use different run times or like more horsepower depending on the use case. For like, for example, for if data scientists are doing deep learning or something, so we can spin up like GPU nodes in it. Job cluster is basically it's a cluster which spin up automatically to do certain tasks and terminates when the job ends. It's isolated, like it's not dependent on anything else, and can't be rerun. Like once it's start and terminated, like you can't rerun it. And it's good for those production jobs where you like it's for those data pipelines or those jobs which are like finalized and productionized, or like are in production. There you can use the job cluster. They will come, run the pipeline, and the cluster will die. So in this way, like you are saving, like it's a cost saving approach too. Instead of like running the cluster throughout the day, like you just running the cluster when you need for your job. Pool, that's another thing I want to talk about. It's not type of the cluster as I mentioned initially, but it helps clusters associated with it reducing their cluster start and auto scaling time. By like in pool, they already maintain a set of idle ready to use instances. So if job clusters can't be associated with pool, like all purpose cluster, let's say concurrency cluster is associated with a pool, and like you you set the cluster on auto scaling. um, and we're going to see in the demo how to do it, but like let's say you have a concurrency cluster where you set your cluster on auto scaling and all your resources are consuming everything. Then to increase the to increase the nodes, like it will take some time to spin up the cluster, like spin up those nodes, and like starting those nodes will take time. So this, like if you're like this, if our concurrency cluster is associated with pool, there will be some idle instances or nodes will be there which will be available right away, so it will help to save time. And and there could be a situation when pool don't have any idle instance. So for example, if your pool have, let's say, two idle instances and they both were used, in that case, like pool expand like its instances by allocating new instances or new nodes. It's pretty work it's pretty it's it works pretty same as like a regular pool concept, where like let's say a cluster like takes an instance or release an instance. Like if takes an instance, like it will reduce from the pool, but if they release an instance, it will return to the pool and will be available for the other clusters to use. And we will see in the demo how we can associate a cluster to the pool. And next slide. So to set up the clusters, there are like four main things which you need to keep in the mind, like which Databricks runtime version you want. So basically there is, we have a drop down options from where we can pick which version we want. Same for the node configurations. We have like separate node configurations for the drivers and the worker, along with the numbers of the workers. Auto scaling, which was I was mentioning initially, so we can decide the minimum and max. And we can also, like in auto scaling, as I mentioned, we can associate our cluster to a pool. So in that way, we don't have to wait for the clusters, sorry, the nodes will be readily available instead of the cluster is waiting for the new nodes to spin up or the new instance to spin up. And there is a last thing is the auto termination, which is like basically it's a way of saving money. I was like, if your cluster is idle for a certain amount of time, you can like terminate it. Okay, so now let's jump to the one second. Yeah, let's jump to the demo. Okay, go here. So for the sake of time, I already created a workspace, but I'll show you everything, and so you get an idea how to do these things. So the first thing is like if we go to our Azure portal, the things like we need to search for Azure Databricks. Like you can type Databricks and this service will pop up. You go there. You can see I already have workspace. So you can create your own workspace. You click on create, and it's very easy. Then you select your resource group, give it a name. Let's say Data Tech Demo 2. And then the reason based on your location, and the pricing tier is like standard and premium is there. So for the people who are for demo purposes, we will use the standard, but the people in organizations or like who's using Azure Databricks professionally, for them like premium is there. And if even if you like wanna give it a shot, like there is a trial version too for it. I'm picking standard. I'm not going to I'll click on review and create, but I'm not going to create it because I already have it. But like once you create on this, you will get something like this, like Data Tech DB2 or something, whatever name you give it to the once your workspace is created for the Azure Databricks service, you click on this, and after that you just click on launch workspace. And after like it take very just a couple of seconds, and you will land here. So here this is the Azure Databricks, and it's like it like if you, even if you like go to, let's say, AWS Databricks or directly to the Databricks, your this space, like the workspace, or you can say it will it will look pretty same. Like there is no difference in it. You will find if you're using AWS Databricks, then also it will look same. And even if you're going directly through the Databricks, and if you want to learn Databricks like a off the topic, there is a like a free version of Databricks community version or something which you can sign up, and you will find pretty same. Instead of Azure Databricks, there you will see Databricks. The components I was talking about. So workspace, data, compute is a cluster, and jobs. So workspace, as I was mentioning to you, the workspace is basically like it's pretty much like, as I was mentioning, like it's a project which is isolated. So you can have like shared projects, or you can have projects which are like not shared. So in that, or like a user specific things too. So if you click on this, like I'm the only user here, but like if you're an organization, you might see multiple, or it could be either way. Like shared is basically it's those shared projects which are like multiple teams are working or something like that. But the idea here is to explain like whatever you do, it stays in your workspace, so it's isolated from others, and until you don't share it, it's like it's with you only. Okay. Repo I didn't mention, but like you can you can add any repository to it, like a GitHub and all those kind of things. We are not going to do that, as we are not focused on like how like more on Databricks. This is more as I mentioned, talking about from DP203 perspective. Here it comes the clusters. So as I was mentioning initially, there are like two types of cluster. One is the all-purpose, second is the job cluster, and pool we'll see it later. So all type of cluster, which all-purpose cluster, as we talk, is like used for day-to-day kind of activities. So how we create it, if we click on this, then you give it a name up to the cluster, let's say cluster 2. And these are the mode I was we discussed previously: high concurrency, standard, or single. So high concurrency is for situation where like multiple people are concurrently using the cluster. Standard we talk about at single node, where like there will be no worker, only one node, the driver node will be there. And if you remember on my second last slide, I mentioned there was like to set up a cluster, these are the four main things. So runtime, Databricks runtime. So if you see here, like, so there are like so many like images are already available to us. So based on your requirement, you can pick an image, and this is the Databricks runtime. So these are the standards. Even they have like for machine learning too, which is pretty cool. So you don't have to install anything. Like everything is already packaged for you. Just you select like your runtime based on your requirement, and you're good to go. So that's where like this is very handy. Like you don't have to worry about the infrastructure. We stick to the default version, but this is what like a runtime means. It's like an image already available for you, and you can spin it. And the other two things I mentioned is the auto scaling and enable termination after, so like after certain amount of time in like after certain amount of idle time. So enabling auto scaling, like if you don't want, like you can deselect it. Like in this case, there will be like by default 8 worker loads, but if you do enable, like let's say enable, so minimum will be 2, but if your workload is higher, it goes to the 8. And we have to like as so for worker and driver node, we have to separately like they're independent of each other. We can select which node we want, like what's our memory, how many cores we want. I'm not like changing it because it's a demo, but you can depending on your requirements. And you remember I was talking about the GPUs too. So here, like, it's not a machine learning one, that's why or like it's a standard one, that's why I can't select it. But you have like literally GPUs. If you want to do the deep learning kind of things, like you can have those nodes too. Same for the driver, you can have whatever you want. And the pool thing I was mentioning to you. So the pool, as I mentioned, like pools keep the idle nodes ready to use. So here we can like, I've created two pools like I already had. I'll show you how to create it, but like here you can select, okay, which pool you want. Like if you want your worker types to be coming out of the pool. So in that case, like, let's say if I do this, so for example, I'm just telling you, like, we started our jobs or we're working on it. It's a standard. So let's say we have a job, it's working on it using 3 or 4 workers at the time, but um, like suddenly we got like a lot of data, or we processing a higher amount of data. So the other 4, like through the auto scaling, like we still have like 4 more to use, but they won't be readily available. Like it will take some time to spend the cluster. Even when you create the cluster for first time, like it take time. So selecting those, like selecting like a pool here, it reduce that time. So it's like basically saving your time. And this is for those critical situations where you can't like waste a minute, or like it's for those critical applications basically. Okay, I'm not going to create it, but this is how you create cluster, and there are like 3 different modes which we talked about. Okay, I talk about the notebook too, so let's go here. Okay, you can create a new notebook if you want. I already have one notebook, I'll show you. Okay, so it's a demo data set. So basically I'm using an open data source, the New York City, which we have used previously in other not sorry Seattle, New York yellow taxi data for Seattle. So this is an open data source available in the Azure data storage. So I'm using the same Azure blob account, containers, all this information I pulled from the Azure portal. I just want to show you, like, if you work with Spark or you already have some experience from Azure Synapse Analytics, you will you will see, like, on the first two cells, we basically, in the first cell we are defining the token, what's our path, where is the file, what's the container, what's the account. So this is the open data storage, this is the container name, that's the path, and this is the SAS token for that open data sets in Azure blob storage. And after that we just connecting to it. Here we just like connecting it. After that, like, once these 2 setups are done, like once you set up your connection or mounted your data lake, it's pretty straight, it's pretty simple. I won't say it's simple, but it's exactly same as Spark usage. You can see that we are reading the file, the Parquet file, into data frame, then I'm printing it, and after that just displaying it. So if you understand Spark, like these 2 cells will be pretty easy. And these 2 also, like if you come from if you have seen my previous videos, this is like basically we connecting to a open data. And the other thing I want to talk about, these notebooks are pretty same as the Jupyter notebooks I was talking about. And here you can do like visualizations too. If you click on this, like this is a dummy visualization, but you can literally, let's do this. I'm just playing around, I don't know, but you can like change things and do stuff like so you can do the visualization also here. Okay, so here, like, you can, and the other thing is like as like Jupyter notebook, or not Jupyter notebook, like Azure Synapse Analytics, you can use your language. Like you can do different language, you can go SQL, you can go Python, you can go Scala, using the magic command, like for example, if I go here, like SQL, this will give you SQL or something, or like if you want Spark, something like that. Yeah, so you can switch your languages too. I started, like when I created this notebook, it shows Python, but you can change your language even in the different cells. It's pretty same as like pretty standard as like notebooks. Okay, compute pool I was mentioning. So there's like these two pools. Like so far we haven't like attached anything, but like you can create a pool and let's say give it a name, demo pool 3. I'm just making, and then you can make like minimum idle, how many idle instances you want here, and then you pick like what kind of instance it is. Like you have to pick the configurations of your node, and same thing goes for the runtime. So here is the catch, like you keep the your runtime and instance pretty same as your cluster, or like the cluster one, keep your cluster ones same as the pool. Okay, so that's how you create a pool, and we saw like how you can associate a pool. Like when you are creating a cluster, you just need to select a worker or driver node and pool existing pools. The job cluster. So here you can create a job. When you create a job, like you can see, you can create a new job cluster, or you can pick even existing all-purpose cluster. So new job cluster which will spend like when your job is running. Once the job is finished, it will be done. So let's say task. I'll create a demo task 2. Select the notebook. I go to users. Let's say hello world. This is a very simple one. I do hello world. If I want, as I mentioned, I can use this one. If I want, I can use this one. Create. So the task is created, like nothing is run so far, but because there is no schedule, if you click on schedule, do it this, and let's say it runs every month on 1st. I'm just making it, or you can show the ground syntax too if you want, but save it like so. Basically this job will run on 1st of every month at 3:23, and you can run it manually too, but but here we have created a, like it's using a job cluster. It's not using any existing cluster. So when this job will run, this cluster will spin up. As this job is done, the cluster will die, and like the cluster will terminate. Okay, so anything else we're missing? Yeah, so that's pretty much for this video. So the main things on which I want you to focus is the understanding of like types of clusters and the pool, because in exam they ask about these things, like okay, they give you a scenario and ask, okay, which cluster need to be used, and this is like in the last 4 questions of case studies where they ask about these things. In today's video, we're going to talk about data security in Azure, more specifically data encryption in various services and dynamic data masking. So without further ado, let's start. First thing, what is data encryption? Basically, it's a mathematical function which encodes the data using a key, and only users with the access to that key can read the information. There are 2 types of encryption: symmetric encryption and asymmetric encryption. In symmetric encryption, same key is used to encrypt and decrypt, while in asymmetric, a different key is used to encrypt and decrypt, and a different key for decryption process. One of the key is known as private key, other one is known as public key. So if you look at the like diagram below in this slide, like let's assume this is our data. So we use, like if it's a asymmetric encryption, we use this approach, like the same key is used to encrypt and same key is used to decrypt. So it's very intuitive, and same thing is here. So why, like this is just basic information about like what is encryption, and what kind of is it and where it is used. Basically, encryption is used to save our data um, from like hacking or like from anybody outside like our organization. We don't want them to access our data, or like when we are using our data over network, we don't want other people to read it. So that's where we need the encryption, even in within organizations too. Due to the compliance and all those stuff, data should not be roam around freely. It has to be encrypted. Okay, now we look into the data encryption for various Azure services. And data encryption in Azure is used in many services, but we will be focused only on the services which are used or related to data engineering. So if you look at this chart, like the main thing is if you look at this slide, it have a table which shows like for specific services in storage, what's the encryption for like rest and motion, who manage the keys here, and I'm talking about the same keys which we saw in asymmetric and symmetric, like the key, and is there a double or second layer encryption option is available. So we'll start with Cosmos DB. In Cosmos DB, data is encrypted by default, both for rest and transit. So the people who don't know what is rest and transit, the rest is basically when data is stored and then nobody's using it. So that's on persistent storage, that's encryption, like that's data at rest. And if that data is encrypted, so we call encrypted data encryption at rest. And transit is where data is in the motion. So basically, when we are moving the data from one system to other systems over the network. So in Cosmos DB, both uh, data at rest and transit, both are encrypted by default, and there is no way you can turn it on and off. Like it's encrypted. And the encryption used for the type of encryption for rest is AES 256. I don't work like we don't need to know about the details of it because that's more for the security people, but just for our understanding or like just for our knowledge, we that's why I mentioned there. The encryption key for the first layer or the default encryption, because here like when you create a Cosmos DB um, Cosmos DB storage, like the first layer, or you can say there is a default encryption. So for that, who manage the key? So those keys are managed by Microsoft using the service managed keys. These are like we can't change it to anything else. These are by default. And nowadays, to increase the security, like we can have a second layer of encryption in Cosmos DB using the customer managed key. So customer managed key, the keys are of the customer who or whoever is creating the Cosmos DB. And as I mentioned, like it's as the name says, these keys are managed by customer. It could be in Key Vault, it could be in the data center, it depending on like like how they want to do that encryption. Like they want to do it on the client side or they do it on the server side. But the main thing is encryption at rest and transit is by default. We can't turn it off, and that encryption is managed by Microsoft using service managed key. But if you want, we can do a double encryption using a customer managed key. So let me show you 1 second, like what that mean. Okay, let's go to our Azure portal. Okay, and Cosmos DB. So when you create like when you click on this create Cosmos DB account, and we will pick Core SQL API. I pick by default this, or I don't need to do this. I was talking about this. If you click on this encryption thing, so here you will see this one option like data encryption. So this is the second layer. This is not the first layer. The first layer is automatically. This is the second layer, and sorry, yeah, this is the by default. If you need the second layer, you have to click here, and then you have to provide the customer managed key. Okay, And if you do this, like the first layer is still going to come. So if we look at this image, 1 second, it's going to look like this. Your data, the first layer, you can say encryption with service managed key, and the second layer is the encryption with customer managed key. And how we do this is basically, if we go to portal, when we are creating, if we keep it this way, only one default encryption will be done. And if we click on this, that will create the second layer on top of it. Okay, let's go here. Encryption of Data Lake Gen 2 is set up during the account creation, pretty same as the Cosmos DB. And here also it is always enabled by default for both REST and transit data. Encryption at REST is transparent, which automatically encrypts prior to data persisting and decrypts prior to retrieval. So data is always secured in Data Lake Gen 2 using HTTPS. And we all know HTTPS is a secure protocol. We can either manage, like for here, like how this default encryption, like who manages the keys here. So here we can go either, like if you want to do service, like Microsoft our platform using service managed key, we can do that too. Even we can do the customer managed, but by default setting is the Microsoft using service managed key. But if you have your own keys, you can use that too. And here the double encryption or the second layer of encryption is enabled using a setting name enable infrastructure encryption setting. So let me show you very quickly how we do that. If we go here, let's go this, and here also, like we don't have to create it, like just for understanding. If you go here, and I already have one, but I'm not sure like what I put it there, but I'll go create a new one. So if you click on this, and here we have encryption option. So for default we have both. If you want to go with Microsoft managed key, that's also okay. If you want to go customer, that's also okay. In case of Cosmos DB, it looked like same, but in case of Cosmos DB, if you don't select anything, first layer will be Microsoft, and if you select customer, that means the second layer will be the customer, not the first layer. First layer is still going to be the Microsoft managed key, but here the first layer itself will become Microsoft, or like if we select this, that means the first layer itself is managed by customer. And if we have to do the double encryption, we have to select this, and we need to keep this in mind, like, and they give you the warning, like this option can't be unchanged after this storage account is created. And let's go to the slide. Hope these two make sense. And the last one is the Azure Synapse Analytics. And like we need to keep something in mind. Like when we create Azure Synapse Analytics, we create a workspace, and in workspace we create pools, SQL pools. So the workspace by default is encrypted, even at rest and in transit, but the pool is not by default. Like it's by default, it's not encrypted. We have to manually do it. Okay, let me show you very quickly. If I go here, 1 second, I already have a Azure Synapse Analytics workspace already. So, and in this, I already have two, like this is the built-in serverless SQL, but this is the SQL pool. If I click here, and like if you select your SQL pool and you scroll down and you see transparent data encryption, so you see this is by default off. The workspace in like, and if I go there, this workspace is encrypted, but that pool is not encrypted. Hope that makes sense, like it's not confusing. So the workspace is encrypted but not the pool, and you can encrypt the pool if you want to, like just by this button, and you can save it. I don't want to make any changes, but that's how you do this. So the difference you need to understand is the workspace is encrypted, not the pool. and data in transit is encrypted by default using the transparent layer security. Okay, and here also the how this is managed, like it is basically like the first layer of encryption is managed by Microsoft, the keys, and this is workspace level. And the second thing is the second layer of encryption we can do through customer managed keys. So let me show you how to do that too. Let me very quickly go to my portal. And this is I'm talking about at workspace level. Okay, we go here, create a new workspace. Okay, and if you click on security, so you see the double encryption, and this is the same. The double encryption is when you're creating it, and if you enable in all three, it can't be undo. Here also, like you can see, if you want, you can enable double encryption. Just click on this, then you have to select your key, which most of, like it depends, but most of the time it will be in key vault, but it could be in your data center too. Okay, so hope that makes sense. Like double encryption is available in all three through customer managed, uh, in Cosmos DB. In Cosmos DB and Azure Synapse Analytics is through customer managed, but here it's through one setting. And the first layer, which is this, like if you look at this diagram is very simple representation of encryption. Let's say this is our data. There is one layer of encryption, then there is a second layer of encryption. So for the one layer in Cosmos DB, Microsoft managed keys are used. Same for Azure Synapse Analytics, but in Data Lake Gen 2, we can go for customer hit, like the customer managed key too. And in the other two, like this layer is customer managed key, but for Data Lake Gen 2, they have something I don't like. We don't know the details of it. That's not required for us at this point. But if you understand this thing, and like it's more than enough for DP203, because there is no way you can like you don't need the details of like what kind of encryption is it, because if that's for like security folks, but not for data engineers. Okay, let's go to data masking. So the next topic is the data masking. So data masking is the process of hiding the original data. It helps to limit the exposure of sensitive data to the user who should not have access to data from viewing it. So if you look at the picture, we can observe that sorry, let me go back very quickly. So all the digits are not visible. Let's assume this is a phone number. This is like telephone number, but all digits are not, like only last three digits are visible. So this is the way of hiding the data. Like, and even nobody can make a guess about it. Okay, and this is like data masking is more about the access control, and data encryption is more about like where you want to secure your data from outside world. This is more like we don't want to give access to non-privileged users, and it is only available in Azure SQL database, SQL managed instance, Azure Synapse Analytics, and in with the name of dynamic, like with the setting dynamic data masking. It's not available in Cosmos DB or Data Lake Gen 2 or other services. It's basically available here, and it can be enabled through Portal or T-SQL. So basically it can be done directly on the Azure Portal site, or we can write query. I'm going to show you both, but it can be done by these options in Azure Synapse Analytics and other services. Before we jump into like how to do it, like the other thing which we need to know, that's like a type of data masking. So there's like 4 types of data masking available currently in Azure. The first one is the default. So the default is basically full masking depending on the data type. So what that means, let's say if you have like a 4-character varchar field, it will cross it out. If it's an integer, it will put 0. If it's a date, it will put something like that. So depending on the what kind of data type it is, it will fully mask that. Like no, not like if we were looking the last page, like this is a telephone number, but last 3 digits are visible. Here, nothing is visible. Email, it exposed the first letter of the email and the suffix like .com. So for example, let's say this is anand@gmail.com. So we can see only A and .com, not even Gmail. What's in there, we don't know. The third type is the random masking. It's a function used is used for any numeric type of masking. The original value of will be replaced with a random value basically. And the last one is the custom, where this custom function is like only first and last digits are visible, and in between we pad something like 0, 1 or X, whatever we want. Okay, let's do a very quick demo for it. Yeah, let me go to web portal. Okay, 1 second. So I'm using Azure Synapse Analytics to show you this, and we're going to do it through, I'm going to show you both the T-SQL and the portal too. So let's go here. So you understand this. This is, I already created a dedicated SQL pool. So if we go here and like if you refresh it, there is no table. So I have a script ready which shows like how we create this. So if we look at this script, the first thing is we creating a schema. So I've already created the schema, so I'm not going to redo it. Like I'll just show you, this is a schema already existing. And after that, I'm creating the table with the masked columns basically. So here is the table name is the membership, and it have these fields: first name, last name, phone number, email, discount code, and all those. And you guys have seen all this, like this makes sense, nothing crazy, but from here to here, this is the thing, which is, this is basically the mask function. So the type of masking we want to do, so we use this like a keyword masked with bracket start function, and then depending on the type of masking you do. So this is the default email random number, which we already talked, and this one is the custom. I know like they use partial key, the partial as a word, but this is the custom. So what happened here in the first name, like it starts with 1, and then in between it will have 5x and then followed by 1. Okay, so even somebody's name is very big, for that also it's going to show like that, so nobody can even make any guess about it. For phone number, it's default, so everything will it's bar chart, so everything will be cross out. Email we already mentioned, the first digit, so first alphabet and the .com will be visible, and this will be the random numbers. Okay, and let's see, if I go here, we don't have any tables, so let's run one script very quickly. I'll change it to data masking. As I already mentioned, I already created the schema, so I'm not going to run this. I'm going to run first create table. Okay, paste here. 1 second, sorry. Perfect. Run. Okay, so query executed successfully. We can check in our data. If I refresh this, so the table is created. Now let's just insert one record, and this is for sample. There's like if you want, you can put more, but this is just to make you sure. So we're putting some values in it, like first name, last name, what's the telephone number, what's the email, and all those. So this is the data we're putting in. We run it. If that runs successfully, if we do this, so like so far, like you will be like, okay, we created these 5 columns as masked, but I logged in as a admin, so I have the privilege to see unmasked data. So what we need to do next, we need to create a new user and give that user only read only or select only permission, and after that we will see what will happen. I'm not going to execute these two because I already created the user. So basically here, like I'm creating a user name
masking test user, and after that I'm granting only select only permission to this user. Okay, so if I run this, I'm trying to impersonate this. So if I run this, and you need to keep in mind, 1 second, like I'm using revert, so like I go just to come back, but if you don't want, you don't have to do it. Well, let's run this. So you see this? So everything like discount code is I don't know, this is a random number, and we see this, this, and this. Okay, 1 second, let me quickly check. Perfect. And if we revert this, let's do this. So now revert, basically I'm back to as an admin, and I can run it again and I'll see everything. Perfect. So this is masking, which we do through the like T-SQL. If you want to do it like and as I said, there's other option to do it through the portal. If you want to do from the portal, you can do that too. So that's not a problem. If you click on this, this is the Azure Synapse Analytics workspace. You go there, click on this, and if you scroll down, you will find dynamic data masking. You click on this, and you can see like these things which we already created the rules, so it's already there. Only one column left. If you want, you can click on this add mask, select the schema, type what column you need. Rest of the columns you can't pick because they already grayed out or they already masked. So we can pick this, and then depending on like what kind of you want, like default, credit card, email. Like here, let's go with default, add, save. So in this way, like that's done successfully. So in this way, we can add dynamic masking from here too. In today's video, we are going to talk about the Azure SQL or Azure Synapse Analytics auditing. So without further ado, let's start. Those who are not aware about auditing, so let's first understand what is auditing and why we need it. So auditing, as we might have heard in banking domain or in other organizations, where basically it means it's inspection of various books of account to make sure all departments are following the procedures and regulatory compliance. So in a similar way, data auditing helps us to maintain the regulatory compliance and keep an eye on the database activities. It helps us to gain insight into discrepancies and anomalies that could indicate business concern or suspected security violation. In Azure SQL database or Synapse Analytic, auditing policy can be defined at specific to the database or at the server level. So basically there are like two types of auditing policy which can be defined at server level and specific to database. A server level data policy applies to all database exist in that server, and even if you create new servers, like it applies there too. And there is another thing, if server level auditing is enabled, and it always apply to the database regardless of database in auditing setting, like database auditing setting. So basically, let's say if server level auditing is enabled and database auditing is not enabled, still database will be audited due to the server level auditing. And these auditing policies write logs, write these auditing logs. We have the options to write these logs into three things: Azure storage account, log analytics workspace, and event hubs, depending on your requirements or like how you want to like keep an eye on your audits or what resources you want to use. You can go for either of these options. Okay, so now let's jump into the demo. Okay, basically so I have already created an Azure Synapse Analytics workspace, Azure SQL server, and Azure SQL database. So we'll start with the server. So you open the server and just scroll it down, and here you see in security auditing. So if you click on this, I've already enabled Azure SQL auditing like here, but when in your case you will something like this, like which means like Azure SQL auditing is not enabled at the server. So you can enable it just clicking here, and as I was mentioning, you can decide in which location you want to store your audit logs. So I've picked audit like log analytics. You can do it in Azure, like Azure storage or event log. And in server level, we have another option of auditing the Microsoft support operations. So there will be operations which are done by Microsoft support engineers. We can keep an if you want to keep an eye on that too, we can do that too. So this is how you enable auditing in server. And as I mentioned, like once it's enabled in the server, all the databases within that server will have by default Azure SQL auditing. Now let's look into like how we enable this in a database. So this is a database. So if I scroll down and go to security again, click on auditing. So pretty same as we saw in the Azure server, but here you see like server level auditing is enabled because as we saw like already enabled in the server, but we can enable it if we want at the database level too. And same we have, then we get the chance to pick at one location where we want to store our logs. Okay, and last 1 second, I'm not saving it, like I just want to show you like how to do this. And the last one is Azure Synapse Analytics. If you go into Azure Synapse Analytics and you scroll down, like same security Azure SQL auditing. So I've enabled here, like it's the same thing. You just with the button you can enable and disable it. And where we see the logs, so let's go to sorry let's go to the database. And if you want to see the logs, just scroll down, go to the auditing, and you see view audit logs, because I have saved in the what's like log analytics workspace, but you can store in other places. So here you will see log analytics workspace, like there, then you can see what's the server audit, what's the database audit logs. And in the logs you will see the activities. Here you're not seeing anything because I haven't created anything, but generally in logs you will see who like new databases are created, anything is deleted, like some tables are deleted from the database. Those kind of things will be logged here. So if any and then we can do an analytics on top of that too, and find the insight of anything which we were mentioning, any discrepancies or any anomalies are detected. Then we can take a deeper look why that's happening, or even need to protect, like if somebody accidentally database log, to find like who did it or these kind of things. In today's video, we're going to talk about the row level and column level security in Azure SQL and Azure Synapse Analytics. And be more specific, we will be covering what are row level and column level security and how these can be implemented in Azure SQL or Azure Synapse Analytics. For your information, row level and column level can't be applied in the Azure Data Lake Gen 2 and Cosmos DBs. We'll start with the row level security. Basically, it's a mechanism to restrict records, read and write access based on the user context. As we can see in the image, like the row number third is restricted. So what that means is like some users won't have access to the third row. And what are the typical use cases for that? So like one of the most typical use case in the real world is when people are have shared hosting or multi-tenant tenants in situations where common database tables used by multiple tenant to store the data. And in such cases, we want each tenant to restrict access to their own data only. We will see in the demo more, like it will be more clear, but the basic idea is like some people will have access to
limited data only. They don't have access to everything. So another example, like which you guys must have seen in the traditional databases, is where we want to control the access to rows based on the user's role. So example is like, for example, in sales department, sales manager will have access to all the rows in the table, while his reportees or direct reportees can see the records that applicable to them. Okay, the next is how we implement row level security. So it is done using the T-SQL by using security policy. So if we look at the image, so basically we need to create a security policy, which you can look into the example shown on the screen. So basically how we create a security policy, it's like a create statement, security policy, and then followed by the policy name. It can, like, I'm in the example here, it's direct name of the policy, but it can be schema.policy name. So here the policy name is the player's security policy. And a policy basically contains two main elements. One is the security predicate and predicate function. So if you look at the green box here, so this is the security predicate, and the blue box inside the green one is the predicate function. So predicate function is an inline table valued schema bound function. I know, like, it's sound very complicated. Basically it's a user defined function which determines a user executing the query will have access to the row or not, based on that logic we defined. And security predicate is the one which binds that predicate function to the table. And it can be of two type, filter and block, but block is not available in Azure Synapse Analytics. So in demo we won't do the we won't talk about block. We will use the filter one. And the yellow piece is basically, it's when it notifies that the security policy is enabled here. I know, like in this the image we have on the screen, it we are not showing the predicate function, but we will see in the demo. Okay, cool. So let's jump to the demo. 1 second. So I've already created a workspace for in Azure Synapse Analytics, and also a dedicated SQL pool. So if we go here and let me refresh. 1 second. Let me reload this. And this is the like, I already created this script which we want to use, but we will break it down into we'll look into this script one row by one, so we'll understand what exactly we're doing. So let me copy this. So we doing column level first. Oh, sorry, the row level. Let me copy this and copy it in one of my editors to make our life easy. Let's change it to SQL. Okay, awesome. So like first 25 rows, or even like first 30 rows, are very basic, like you get it. So we basically create a schema named sales, then we creating a table with the name of reason, like in that schema, which have ID, sales rep name, reason. 1 second, there is a typo. Let me fix this. Yeah, perfect. Then the customer name, and then we are inserting the sample data here, and I just built some random sample data where you can see we have ID, wrap names. So wrap names, you can see they are repeated, like Mon and Anna, they could be repeated, Cuckoo, Abhi, and all those. And these are random names I picked. And these are the location, the reason we talking about, and the customer. Then after that, the customer name. And as I said, it's a sample data, so I inserted some random numbers there, random names there. And after that, we just simply looking at the records in that. So till here, like, you will be creating a table, like we're creating a schema table, inserting the data, and just looking into that. So we'll first do this. And when we are doing this, it's like we are the admin, so we'll see it as like it will be executed as a admin, or like you can say DBO user. So far we haven't created any users, which you will see we'll create after this.
So let me go into my Azure. Okay, so currently we don't have any table in here. If we expand, nothing. So let's create a new SQL, new table. Okay, and we remove this. And just FYI, like I'm running this for first time, so if anything goes wrong, we can fix it here. But let's go one by one. Let's first create a schema. Run. That's done. Then create a table. Perfect, that's done. Now insert the records into it. Yeah, that's good. Awesome. And now we're just looking all the rows of that table. So you can look, we have 12 rows which we inserted and all this information. And as I mentioned, this is like this is as a DBO, like it's as an admin, like we haven't created any role or any user, so admin have access to everything. Okay, so let's go to our editor one more time, and now let's create some users. Okay, so we'll create 4 users. So one will be the sales manager and the other 4 will be Man, An, Abhi, and Kuku. These are like the random names I put it here in our table for the sales rep name. So we're creating users for them. So we'll go there. So this is also straightforward, nothing confusing till here. So we can run this. Perfect, this is executed successfully. And after that, if you look, like we are giving them read access to all the users. So when we give them read access, so let's go here, do this. So now all 4 sales reps and the sales managers have read access to it. We haven't implemented the row level security yet. It's so far like we created the table, inserted some records, then created users and give them read access. So now here comes like our row security level thing. So if you want, you can create a schema, like a separate schema. I think like that's a good practice to do it. If you don't want, like it will be stored in this schema named DBO. Okay, so what we're doing here, we're creating a schema for our security policy. We go here and enter this. So basically just simple, we're creating our schema. That's done. And this is our predicate function. So what this function, so for let's before jumping to predicate function, let's look. So this is our security policy. So we're creating our security policy name my sales filter policy, and here if you look at this, we adding filter predicate, and this is our function, which predicate function, and we are defining our logic, like how we want to filter out our users. We're defining that logic here, and it's very straightforward. If you look, like we pass the sales rep name here, and then we return we return 1 for if sales rep name is the username. So username is this is a like function, so whoever is the user at that point, it will try to match with that, or otherwise it's try to match with username. So with this simple condition, we're filtering out so for example, if Man is the user, Man should see only records related to her, and same for the other reps. So this condition, like this where clause, is the logic behind it. This is the how we're filtering out things. It's not very complicated if you think about it. It's like it's returning 1 for those records where sales rep is Man, and so it will filter out those record those, it will like filter out those records which are not have sales rep as Man. Okay, so this is pretty straightforward. So what we'll do, we'll first run this function, our predicate function. So go here, schema is already defined, we run this. Perfect. And after that, we run our security policy, and you can look into the security policy. This is the policy name. This is like our predicate function, and we are applying it on our sales region table, and we keep it as on. So if we want, we can like if you want to turn it off, you can just put it off and it won't be applicable. But here we are applying this, so we'll do this. Do Now let's create the policy. Awesome, that's done too. And now what we're doing, we applying this policy on our users. Okay, so we go here, run this. Okay, 1 second, let's try one by one. Yeah, for some reason we can't run all of them together. And as I said, like I never run this, it's just running for first time. Perfect. And let's do the last one too. Perfect. And now we will see how this the security policy is applicable and how it works. So if we go here and if you look at this, so what we are doing here, we are executing, we are running this query as a user as man, and then we will see only records which man have. So if we go here, run this, so you see, so we inserted 3 records, so that's all we see. And at the end, if you see, I have reverted this, so basically it means we're back to our admin role. So if I do this again, like after the revert statement on line number 75, if I do this again, we should see all the records. Oh no, my bad, because the policy is on, so policy is not applicable for DBO. So what we can do is like we can go to the sales manager, we can run this. Line number 75, call. Oh, sorry, I didn't select everything. So here you see, we see all the records. So now the policy is on, and for sales manager, if you see our condition, like it says, if it's sales manager, like give us all records. So like give, like it will return 1 for all of them. So this is how like it works. We can like apply this for other users too. You will see like if Anna, like if we run this, like we'll see only Anna's record, then Abhi's and Cuckoo's. And if we wanna like disable this policy, we can simply run this command and it will disable. And for cleanup, we can run like these commands too. I'm not going to do that. Like I want to jump to the column level security, but you guys get the basic idea, like how it works, what need to be done. So main things need to be focused is on the security policy and our predicate function. And predicate function is like is a user-defined function, pretty much like a user-defined function you will see here. And it's straightforward, nothing crazy. Like you returns the table with schema binding. Here we are doing the binding thing, and what's the condition here is basically we are trying to match the username. Username is a built-in function in SQL which tells you who is the user. So for example, in this case, when we run this, the user name will return, like this function will return man, and in this case it will return sales manager. So based on that, it will returning 1 specific to the row, and those rows are getting filtered out. So this is how we apply a role level security. Now jump to, and I'm going to attach this script in the description. So don't worry, so you can practice along with it. Now let's jump to the column level security. Okay, let's go. Sorry, my bad. Yeah. Column level security, as the name suggests, and we have seen with the row level. So in column level, basically, like it allow customers or users to control access on the table fields based on their based on the user's context or group access. So as you can see from the image, like some users won't have access to the first column. And the typical use case, like which you will see a lot in real world, is uh, wherever we have PIA, like personal identification data, uh, there we need column level security a lot. So data masking is one way of doing it. The other way is like we don't show the data at all. Like we don't give the access to that column at all. Basically, the PIA data, or like sensitive data, you can say, only authoritative people like in the teams will have access to that. It's not like everybody have access to that. And these data points are generally like a social insurance numbers, social security numbers, your phone numbers, even credit cards belong to this. So anything which can identify a user is generally fine, belong to this category. And in most of the financial services, like only limited people will have access to this, not everybody. And same, another example could be like healthcare. Like in healthcare also, there is like a lot of sensitive information, so which only doctors or their assistant should see, not the billing department or accounts department. So in those cases too, like this is very helpful. uh, the implementation of column level is also using tsql, but using the grant command, and it's pretty simple relative to row level security. There we need like a couple of things. Here we just need the grant permission, and which make our life easy. So here's the syntax. Like I know like it look a bit bumble jumble, but like once it's pretty simple. Like grant what kind of permission we want to give, on what object, and to which user. Basically this is the thing, like what kind of permission, which object, and no, sorry, grant on which object, what kind of permission, and to what kind of database principal, like with user to a group or something like that. So let's look this also in a demo very quickly so you will understand much better. Let me go back here. I have the script for this too, and if you see, it's much simpler than the row level. Okay, let me copy this to my editor. Again, Control A, Control C, here, Control N, Control V, and we will go through this SQL very quickly. Let me change it to SQL. Okay, perfect. So here, I think like the first 20 rows are very straightforward, but we'll go. So we creating a new schema named sales2, then we having a table underneath is with the name membership, which have first name, last name, phone number, and email. So basically we have one, so SIN stands for social insurance number, which is pretty same as social security number in States. So we creating a table which have sensitive information, then we inserting the information as you can see, it's a dummy data. Like I'm not using real social insurance numbers here, but we want to test like how the column level thing works. So creating a schema, creating a table, inserting the records, and then creating a user with the name test user. And after that, we using this grant select on, and to this, and giving the membership to giving the permission to this user. And if you look into this like very closely, the table have like first name, SIN, last name, phone number, and email, but we are not using SIN here. So if user try to access the table, they should get an access. So let's very quickly run this. So I'll run first 20 records in one go because it's very straightforward, nothing complicated or surprising. So let's do, oh, sorry, my bad. Go here, a new SQL script. Okay, this, and I'll change it to our data text SQL. Okay, I'll run by run. We should be able to run it together. Let's give it a try. Perfect, we are able to run it. And let's very quickly check like what we have in there. So I'm just checking whether like a table is created successfully. I know like we didn't get the error, but it's always a best practice to check stuff. Okay, so we can see all 4 records here, and our sample data we can see. And now we will run this, okay, which is to give our test user permission only on specific columns, not all the columns, or we can say not. Okay, we need to do one thing here, because we have multiple schemas. So good practice to give the schema name and run this. Perfect. And now we are executing as a test user, and we will see what we get. We should get an error because we're trying to run a query to see all the columns, which, see, perfect. So you see here like the select permission was denied on column. That's why we can't see anything. And if we do this instead of select star, if we pick the columns on which the user have permission, we should be good. See, perfect, boom. So we don't see the SIN or the social insurance number here. So this is the way, this is how we implement the column level security. So in nutshell, column level security is done through using the grant permission, which you can see grant. We give the grant read permission on this table, on these columns to this user. So it's really easy to understand. Like grant is the reserve keyword, then select is the like we giving read permission on this table, on these columns to this user. And after that, like we impersonate the user and try to see if we have the access as we saw. If we do the star, like we get the error. Otherwise, if we pick only those columns on which we have access, we're good. And for the row level, the main thing we need to keep in mind is like we need to create a security policy, and we need to create a predicate function, and which is straightforward. Like our logic need not to be very complicated. It's like based on your role name and all those. One thing we need to be keep in mind, like in row level, like things can get complicated if we have multiple tables, we want to join them and all those. So we need to be a bit cautious there. But if you understand your data well, like it should not be a problem.